converted to text, and then there is a natural language understanding which is derived from the text, and that is fed to the engine which is running at the back end that plays your song, okay, song or whatever the request you are making. Okay, so these are the different phases of conversion which happens from your analog voice to a real-time audio or a video which you are playing. Similarly, you can also, Baidu is one of the application which uses machine learning algorithm in the back, which, where you can search, like Google search, you can also use voice as search method for searching the data which you want. Okay. So there is, at the back end, we have machine learning algorithm which picks up your voice, converts that into text, and the text is converted into a natural language which can be understood, okay, by the machine, and then based on that the machine will respond to your request. So this is how the natural language or the natural language communication happens. So the natural language is a language between the humans they speak or they use for communicating, and the humans will understand, or the first is they will interpret and they will understand what the other person is trying to request. So if both understand what the other person is saying, and if their understanding or the communication is happening between two persons, such communication we call it as full-way communication, which is also expected in machines. Okay, so now we are expecting the machine to communicate between each other, and they should understand. If there is a full-way communication between machine, then we say we have the machine is able to understand, or machine is able to communicate between each other. So natural language processing plays a major role in communicating between machines, because the machine should understand. They should communicate. The other machine should interpret and understand what the communication was about. Okay. So in this, the input, the machine's input is fed to, which is a speech, which is converted to text. Then we have a natural language understanding, which tries to interpret the text and tries to eliminate the ambiguity. And then we have next is the natural language generation, which is actually the output. So where do you find these applications, or what are the applications of natural language processing? One is speech recognition, which you already seen from the previous slide. There is Google Assistant and Siri. The search result that was also seen in the previous slide, like Baidu, Google search. They are using the natural language processing to recognize the voice and convert into text, and then convert into understandable format, and then give the result or output. Then we have sentiment analysis, which is also part of natural language processing. Then we have machine translation. That is the best example is the Google Translator, which converts one language to another language. Okay. So this uses machine learning algorithms plus the NLP to ensure that translation is to the required communication. Then email filtering, that either it is a spam detection. So all these are few of the examples where the machine learning or the NLP are used. In business, the machine learning algorithms ensures that they monitor and analyze the feedback, because, for example, if Flipkart has to project the big billion day, or Amazon has to project some new sales, then it has to understand the feedback. It has to analyze the feedback based on the previous release. How many products got sold, how many different clusters of products which got sold, and what will be the user experience based on that sale. Based on the feedback, the next year's business, or the next year's big billion day, or the next year's big sales will be decided. Okay, so the businesses are using the data, which is the analysis, the user experience plus the feedbacks that are shared by the user on the portal or the app, that are collected, and based on that the predictions are made, and the business are using such data for predicting the future sales. This was about the user applications, how user used how users are using the machine learning algorithm in their day-to-day activities. Similarly, in industry, the machine learning algorithm plays a major role today. Why? Because today we see industrial revolution. We have already seen three revolutions of industry. The fourth one is what is running now. Okay, that is the industry 4.0, which is more popular today because of the technology revolution which has happened. Okay, the first industrial revolution which we seen was with respect to water and steam, which was used in the industry. The second industrial revolution, what we seen was electrical power. So that was the second industrial revolution. And the third industrial revolution was the computers. Okay, the industry started using computers, or they started automating the machines through computers. So that was the third industrial revolution. Today we see the fourth industrial revolution, which is also called as smart factory, or it is also called as cyber physical space. The word is cyber physical space, or industrial revolution 4, or IIoT 4. So the IoT 4, which is the industrial revolution 4, uses IoT technology plus the machine learning algorithms. So these two put together, or these two together, we call it as a smart factory, or it is also an autonomous system, where IoT and machine learning plays a major role for the industrial revolution 4. The difference, what you can find, is the arrow marks here. Arrow marks here. These arrow marks indicates that from the machines, what we see in industrial revolution 3 to industrial revolution 4 is the communication. Okay, so this is the communication part. It means that the machines can communicate between each other. So the machine learning algorithm that I introduced you at the previous stage, I told that machines should communicate between each other. So then only we say there was a full way communication. Okay, so that is what is possible in today's industry. Even the machines can communicate between each other. That is possible through IoT and machine learning algorithm. So the industrial revolution 4 plays a major role, and which is very popularly used in industries today. And what is the advantage of having, or what is the advantage of IIoT or Industry 4? Okay, so because of the technology integration, the devices now can communicate to each other. They can share the information, or they can share the statistics of their own devices. Okay, so what is the advantage that we gain because of the technology integration is from the raw data, the raw data which was earlier, which was part of the device. Now, from that raw data, we can draw some insights. Okay, what is the performance of the machine? How frequently it is giving outputs? Okay, so it means that based on the outputs what the machines are giving, so I can draw some insight. Okay, for next 5 years, this machine can perform. That is the insight I can draw. Okay, so that's where the IIoT plays a major role, or machine learning algorithm plays a major role. So predictive analytics based maintenance is one of the application of machine learning algorithm. What is the purpose of this? Is to predict probable future machine failure. If I want to predict what may happen in next week or next month, there may be a breakdown or there may be a failure. That prediction can happen 1 month before. How do I do it? Through these machine learning algorithms, which can predict the possible failure or breakdown of the machine. Even today's online tracking, that you are using it for tracking the assets through Amazon, Flipkart, or any of the online retail, the online tracking system where it shows where your order is at that moment of time. That is possible through machine learning algorithm. The machine learning algorithm plus the RFID technology put together, plus the IoT integration, our IoT platform integration to the RFID technology plus the machine learning algorithm. So using these three technology, we can predict the current location of the product through route optimization algorithm, which can predict how much time it takes to reach the destination. Okay? It will tell you another 1 day it will come or 2 days it will come. How do you know or what is that is running at the back end is the analytics algorithm or the route optimization algorithm, which will predict, okay, from the source how much time it takes to reach to the destination. So this is the technology enablement which you are already observing through by using which is already running in the backend through machine learning algorithm. The augmented reality based field support operator service. This is also a major application because it gives you the faults which normal human cannot visualize. Okay, through augmented reality, the fault detection can be analyzed and it can also be resolved. Okay, so that is the advantage or that is the application of machine learning algorithm in the industry. So the industry 4, this is the different steps in which the data reaches or data can be visualized from the industry or the industrial application. So at the last stage, that is the connecting point. This is the point that is the generate where all the devices are connected here through PLC and SCADA. PLC and SCADA are the PLC programmable logic controllers which connects to the sensors and they draw the data or collect the data. So the first step of any industry or IoT 4 is to connect to the devices. Okay, so there should be a connecting point to the devices. Until and unless I connect to that device, a manufacturing device like a lathe, or it can be a machine, or it can be in the automotive industry, it can be a automobile assembly system. Okay, so if I want to analyze what is happening through that process, then I need to connect to those devices. How do I connect to those devices? Is through the sensors. The sensors are used for connecting to those devices. From the devices, you will collect the required information. From the sensors, you will collect the required information. That will be the next step of collecting the data from the sensors. And then once the data is collected, the data is stored to the cloud. Okay, so how do I store the data is by communicating. Okay, so first is connect through sensors to those heavy machineries which are there in the industry. Then once I connect the sensors, then the next step is to collect the data from those sensors. Okay, so next step is collecting the data. Then once I collect the data, immediately I need to communicate it because the storage space that is available in the collect is very minimum, so it can only store minimum data. So I need to transfer those data which were collected to the cloud space. Okay, so how do I transfer it through communicate? Okay. So I will communicate the data to the cloud, and in the cloud the data, real-time data are getting stored, and later I apply the machine learning algorithm to identify the patterns within the data. And the machine learning algorithms will pick the patterns, required patterns within the data, and later it will be it will be sent for visualization for the higher ups or the industry managers or the in charges to analyze. Okay, what is the action that can be taken based on the analysis and based on the visualized data, they will take a required action. So the feedback loop which is coming back is the action taken to ensure that the system is working smoothly. So this is how the industry is using the machine learning algorithm to understand the device and they analyze the data which is coming from each of the devices, and based on the analysis they are going to either take an action, or if everything is going fine, then there is no action. If some improvement is required, then there is definitely an action. So these are the different phases. The companies like Saskin and Siemens, they have a complete integration of the system, starting from the sensors, that is connecting point, to the machine learning or the enterprise application. They have a complete integration. So the complete industry automation can be done through such systems. So once the machine learning, once the data reaches to the cloud, first point was connecting, then next was collecting, then I communicated it to the cloud. Now data is in the cloud. So once the data reaches to the cloud, the machine learning algorithm comes into picture. So the machine learning algorithm, or which type of machine learning algorithm I can use, okay, depends on what is that I'm going to, I'm going to analyze, or what the data I want, what pattern of data I want to analyze. Okay. So based on the problem which I want to identify within the machines, there are 4 types of algorithms that I can use. The first type of algorithm that I can use is called as anomaly detection. Anomaly detection is nothing but fault detection. If you want to detect any fault, then I use anomaly detection. So in anomaly detection, based on the previous data and the current data, based on the previous, I keep a time frame as reference. For example, if I have 2 time slots, T1 and T2, T1 is the reference time slot and T2 is the current time slot. Okay, so the T2 time slot is compared with the T1 time slot. Okay, the data within T2 time slot is compared with the T1 time slot. If both the data are same, if T1 is equal to T2, it means that there is no change in the data flow. So given the condition that T1 is equal to T2 is true, it means that there is no fault in the pipeline or the machine. Okay. If T1 data and T2 data is not equal, it means that there is some discrepancy or there is some difference in the data. It means that the flow within that valve or pipe, or in this case we consider it as a pipe or a valve. It means that if there is a difference in data flow between T1 to T2, it means that somewhere there was a leakage or there is some fault in the valve. So anomaly detection detects the fault within the within the given time frame to the time frame which was defined for the preceding data. So if there is a difference in data, then it means that there is some fault in the valve or the flow of the next type of algorithm that we define is called as classification problem. In classification problem, what we need to do is either there is a fault or there is no fault, or there is a breakage or there is no breakage. Okay. So I need to classify it as either yes or no. Okay. So classification problem, in this classification problem, which uses supervised learning, it means that the data is structured data, because I know it should be yes or no. Okay. So the algorithm is trained based on the data, input data, and based on that, I will either say there was some fault or there is no fault. And the next type of machine learning algorithm that I can use in industrial applications is clustering. Okay, so here I can group up similar items. Okay, this is used for grouping the similar items. So based on the patterns within the data, I can either group it as bearing failure or a lubrication failure. I want to group it as either a bearing failure or a lubrication failure. Okay, so based on the data set, the machine learning algorithm will classify the data and it will group it as either bearing failure or lubrication failure. I can also use the 4th type of algorithm, machine learning algorithm, that is regression, where I can do some predictions. Okay, so based on the pattern or the temperature patterns, I can predict the based on the temperature patterns plus the weather predictions. I can set the room temperature. Okay, so the predictions, when I'm doing a prediction, then I use regression algorithm, and that finds major applications in smart buildings where based on the weather patterns and room occupancy, the pattern based on that pattern, the room temperatures are fixed. Okay, so automatically the room temperature is fixed based on the weather condition reported and the number of people who are occupying the particular room. So the AC is either the temperature of the AC is either increased or decreased based on the occupancy and weather patterns. So these are the few algorithms which is applied in industries, and because of this, the future failures or the based on the patterns within the data, I can group up what type of failures has happened, what type of failures. What are the different cluster of failures that has happened for the particular engine, or I can predict what is going to happen in next 1 month, or I can classify based on the problem. I can classify was there a failure or no. I can say yes or no. It's a classification problem, or I can detect a problem. Okay, so I can based on the preceding data to the current data, I can say yes. If both the data are same, then it means that there is no failure. If there is a difference in data between the previous data to current data, then I say that yes, there might be a failure. So which is nothing but an anomaly detection. So this is how we use statistical methods to draw the or to group up or to ensure the data patterns are recognized from the data set. So in regression problem, we just try to fit the value based on the target value. I will try to fit the I'll try to fit the value based on the target. In classification problem, I will decide either it is on the right side or on the left side based on the algorithm, or I can group up similar items, which is nothing but a clustering problem. So this is the difference. What I initially told, that there is what is called as the revolution which has happened from Industrial Revolution 3 to Industrial Revolution 4. So earlier industries or industry used to have a 5-layered architecture, starting from input-output device, PLC, SCADA, MES, or ERP. Okay, so enterprise resource planning. But today, this has shifted to what is called as cyber physical production system, okay, where the layered has been the layering of these up to SCADA, up to this space, that is from IO to PLC and SCADA. All these have been converted into cyber physical space. In this cyber physical space, each device can communicate to another device. So a device to device communication has been set up. That's where we call it as cyber physical space or cyber physical production system, where one device can communicate to another device, and they can interact among themselves. They can share the informations, and then the final data which is got within that network reaches to the ERP or the enterprise resource planning, where the analysis will be done. Okay, so this is a typical production system where the machines are there. The machines are connected to the programmable logics or the and then from programmable logics through the network, it reaches to the SCADA system, where the control or data acquisition is happening. That is the local storage. Then from there, it reaches to the enterprise applications, where the large amount of data can be stored. Even the temperature within the room can be monitored, and it is connected to the Wi-Fi unit, and through wireless connectivity, it is reaching to the SCADA, where the control or data acquisition is happening. And once it reaches to SCADA, the data will be analyzed there, and then it will be sent to the enterprise application, where the insights are drawn. Okay, so where the visualization, active visualizations are done, and you can take a control mechanism that you want to increase the speed or you want to decrease the speed, or all control mechanism is again fed back to SCADA, and again it comes back to the machines. So from one single point, that is the control room, all the control is happening within the industry. So no human intervention is required in the industrial revolution or the industrial revolution 4. All the systems will communicate among themselves. They communicate among themselves and to each other and to the next level. Okay, so there is no human intervention is required. So human intervention is only required when there is a fault. Okay, so when there is a fault or when there is an alarm of any device failure, then only the human intervention comes into these automated systems. So this is how the cyber physical space comes into picture. That is, today most of the industries are getting converted from the traditional file layered architecture to the cyber physical space. And how it impacts the business. So first application what we seen was the user application, how the user is experiencing the machine learning algorithm. Then the next applications which we saw was the industrial applications, how industries are getting transformed by machine learning algorithm plus the IoT and the cyber physical space. Okay, so how the integration of these technologies have transformed the industries. That was the second applications which we have seen. And the third application, what we are going to see is the business application. How businesses are using the machine learning algorithm. Okay, for any business, what they look at is the end product, that is the value. What is the value that I get by using machine learning models? Okay, finally, I want to integrate the machine learning algorithm into my business. Means that finally I look at the business values. What additional business that these algorithms can give to me, or what is the future predictions that I can get from these. Okay, so finally the insights are drawn. Here I need to draw the insight, and then from there I need to do the prediction. Okay, so that is the value, business value. The predictions is nothing but the business value. So in next 10 years, your business will be like this. That is the prediction. Okay, it means that based on that only the business will plan. So the machine learning algorithms are used. Most of the businesses now have integrated the machine learning algorithm into their businesses to add value. Okay, so that is where the machine learning is playing a major role today in each of the businesses. There are three, I've taken only three. There are six different architectures which are proposed in businesses. The first is the inference. In inference, you can see that it is a manual based where the data, the inputs are drawn from the external world, and then based on the inference pipeline, the inference or the insights are drawn, and then the predictions are made. Okay, so that is the output. So the input is fed to the inference pipeline, and there is a manual model. In this manual model, normally the microservices are used. Microservice architectures are used to draw the inference, or they feed the data to draw the inference, and then based on that only predictions is done. Okay, so this is the basic model. But businesses will not run based on the single model or the stored model, because every day that the market changes, the inputs will change. The training data set that I use for training the previous model to the current model will change, because the market will keep on changing. Okay, so that's where the training plus inference comes into picture, because today's world is changing, keep on changing every hour. Also, it is even changing every minute also. Okay, so the market is changing. So it means that every time the market changes, then the new data sets are generated. Based on the new data set, the machine learning model which I trained, now it should get trained to the new data set. So we use a data lake. In the business, they use a data lake which is used for retraining the pipeline or the inference pipeline. Based on the inputs, the machine the retraining can happen, and then the predictions can happen. Even that is also not sufficient, because even there may be some policy issues, because in medical applications this comes into picture. The third model comes in majorly used in medical applications, where the policy issues are there because the data are very sensitive. Okay, so someone has to authorize the data. We use human approval. There is a human approval here who can analyze the trained model, the predictions from the trained model. Based on that only the predictions will be made. So this is the third model. So this is how the machine learning algorithms are integrated within the business to generate the values, business values. So most of the machine learning algorithm, what the business is expecting, business is expecting a return on investment. Okay, so what they invested, the output or what outcome is happening should be more than what is invested. So the ROI will play a major role in business. So all these were the applications where you found the machine learning algorithm, starting from the handheld devices or the virtual personal assistants like Siri, all these things, then to character recognition, then in your day-to-day email filtering, that is spam or not spam, to voice recognition like Alexa, Siri, or Cortana. All these have machine learning algorithms. Then we found more applications of it through natural language processing, where like humans, the machines can also communicate among themselves. Even they add value to the business. And we saw how industries are using it for predicting the future failures, that through machine learning and Industrial Revolution 4. How Industrial Revolution 4 has transformed the industries from the traditional 5-layer to a cyber physical space. And then in businesses, it is adding value, that is by through return on investment. The integration of machine learning algorithms, the businesses have transformed the businesses by adding value. So for all these things, you require for implementing the machine learning algorithms, we require some tools, okay, or softwares. Okay, so these are few softwares which maybe in the second session or third session, one of these you may be using PyTorch or Keras, TensorFlow. Okay, so we have Vika also is a popular tool. Vika is a Java-based tool which is more popular for beginners. Okay, so you can also use PyTorch, TensorFlow, Keras. Okay, so these are few softwares which you are going to use maybe in the afternoon session. And you also, what is essential before you start machine learning or understanding machine learning algorithm is you should have some programming language understanding, that is Python, which was covered in the previous session. So last week Python was covered. So I think that understanding will help you out in machine learning algorithm. And apart from that, few mathematical plus the analytical knowledge which is required, that is linear algebra for data analysis, mathematical analysis, then probability theory and statics, then algorithm and complex optimization, multivariate calculus. So this will also be taught up maybe in the second session. Okay? For post-lunch session, you will have experience of it. Now let us try to understand or try to define what is machine learning. Okay, so we have seen all the applications. You saw where exactly it is used and how it is used. Now let us come to the point, or let us try to understand what machine learning, or why you require machine learning. Okay, so already there is a traditional system which is a computer-based system where I used to program. Okay, I used to program, and based on the program used to give you an output. So that was sufficient for few years back, up to 2000. It was sufficient that you can program, and it used to give you an output. But there was a drastic change after 2000, that is 2010, even 2005 or 10. There was a drastic change, and these machine learning algorithms or artificial intelligence, they came into picture. It was there actually in 1950. The first machine learning or AI machine was designed, in 1950, but it has taken a transformational change, and the application, the more application of this we find it today. Why we require machine learning algorithm? Okay, so the machine learning algorithm is required when my programming becomes more critical, means it's very difficult to program. If you feel that I face some difficulty in programming some applications, then machine learning comes into picture. Okay, so machine learnings are used to train computers to perform tasks that would be difficult to program. So if I have difficulty to program something, then I use machine learning algorithm, and they perform the task which was difficult to program. So what is machine learning algorithm, or sorry, what is machine learning is the ability to teach a computer without you programming it. Okay, so the machine is learning on its own. Okay, so you can see the difference in the diagram which is shown below. There is a traditional programming and a machine learning program. So the traditional programming is the programming which you used to do, or which you are still doing it. That is, you give some inputs to that traditional program, and you have already you're using a program which is well written, well coded. So that becomes an input to this traditional programming, and you know what is the output that is going to come. Yes, based on the input, it is going to give you an output. So that is your traditional programming. How it is different to machine programming is, or machine learning is, in machine learning we have data input as similar to traditional programming. We know what is the input that we are going to feed to this machine, and here you can see the difference. The difference is the output is the input to the machine learning. Here you are going to train the machine. Okay, so based on what is that you are expecting, based on that you are training the machine. Okay, so the machine is going to learn based on the output, what it is going to give. Okay, so what is the output of the machine learning is a program. Okay, so it is a program. So now that it becomes a model. That is a model for me. The trained machine learning algorithm, we call it as a model. So the output is a program. So now for this program, if I feed the input, it is going to give an output which is already known, which can be a known output, or it can be an unknown output. But definitely it is a trained, or it is already learned based on the output what it is expected to give. Okay, so the machine learning algorithm gives a program as output based on the input and output, because the machine is going to learn based on the output that you are expecting. The machine is going to learn. So what is the difference between then the next question that you will ask is, already there is data mining which is more popularly used in industry. Why I require a machine learning algorithm? Okay, so you should understand this, because as a computer science or a information science or a IT, this one you should have you should understand what is difference between data mining and machine learning. Okay, because data mining is also popularly used. It's also a machine learning algorithm. It also uses, sorry, it's not. It also uses a machine learning algorithm. Then why I need to have a separate machine learning algorithm? Okay, so there is difference between a machine learning algorithm and a data mining. So in data mining, again, data mining also works on large data set. For that, we need a large data set. Within that data set, within the given data set, in data mining, the data mining will try to identify the new insights. It does not go with the previous insights or the previous patterns or the known patterns. Within the given data set, it tries to identify or draw new insights, or it tries to find new patterns within the data. It is used for finding the new patterns. Okay, so if I want to find a new pattern which was not there in the earlier predictions, if I want to find a new pattern within the given data set, then I use data mining. So data mining are used for finding the new patterns within the existing data set. In machine learning also works on data set. Again, machine learning, what it does is it tries to learn from the previous patterns. Okay, it tries to learn from the previous pattern. So it means that it is not going to give you any new patterns. It is not going to find out new patterns. Okay, it is going to learn from the previous patterns. Okay, so this was the previous pattern. What is the change from the previous pattern? Okay, so it means that based on that, what you are going to do is you are going to predict. So machine learning algorithms are used for predicting. Okay, data mining algorithms are used for finding the new insights or new patterns within the data set. So this should be clear. Okay, so data mining is used for finding the new patterns. Again, machine learning algorithm is uses the same data set, but it tries to learn from patterns which is already existing and tries to draw new insights. It is giving you new insights, or it is going to give you predictions based on the patterns which are existing within the data. So data mining finds in business analytics, where businesses has to draw new insights, then data mining is used. It also works with the data storage, like data warehousing, because data warehousing is the reference for the data. So it works with the data storage. So data mining works with the data storage. Machine learning works with the existing data sets, try to analyze the patterns within the data and predict. The most popular applications for machine learning algorithm is Netflix. You have seen the predictions for the coming week. You can, or when you turn on, you will see the recommendations for today. Okay. Similarly, Spotify. Spotify is also one of the popular application which uses machine learning algorithm for predicting or giving a recommendation. Even Amazon Prime, even today, most of the OTTs are using recommendation or predictions based on the previous experience, or some your friend's experience may be added to your experience and recommendation may be given. Okay, so machine learning algorithms are used in that applications. Even in the banks for real-time fraud detection, credit card transactions. So even spam, auto spam, spam or not spam. Okay, so all these are again machine learning algorithms. So in machine learning algorithm, training data set is required, but in data mining, existing data set is used. Existing data sets are part of the data warehousing. And in machine learning algorithm, we train the data. So we require training data set. Based on that, predictions can be done. So statistical analysis is very essential, which is why I brought it in between data mining and machine learning is these two will use statistical analysis for your predictions. Okay, it will. What are the two important steps within statistical analysis is descriptive and inferential. So we have already seen in business application there was an inference drawn. So they use the statistical analysis tools, which is part of the data mining, which is also part of the machine learning algorithm, which is used as the which is part of the complete data life cycle. Okay, so the statistical analysis part is part of the complete data analysis life cycle, from planning to analysis. So from planning to the analysis and generating the reports. Okay, so statistical analysis is used. What is descriptive and what is inferential? Descriptive gives you a summary of the data from the available data set. It gives you a summary of the data, and inferential uses the summary and it draws the it uses the summarized data and analyzes that data and gives you the results. Okay, so inferential is to draw the results from the summary. Okay, so the descriptive analysis is used for summarizing the data, and inferential is used to draw the results from the summary. So the statistical tools are part of even data mining and machine learning algorithms. They find majorly in when you are trying to predict the population, demand, supply, banking. Okay. So most of the application use that. Then we have deep learning. Deep learning again is a machine learning algorithm, but it uses a neural network to learn. And here there is a huge data set. Okay, we have large amount of data. Then immediately I need to get into deep learning because machine learning algorithms. To draw the insights, maybe machine learning algorithms, we have to come from machine learning algorithms to the deep learning because the amount of data that can be analyzed by deep learning is huge. So the most of the applications, when I started with virtual assistant, which is a deep learning application. The translation, the text translation from English to any other language or any other language to any other language, the translation which happens, Google Translator, uses deep learning algorithm. Vision for driverless trucks or autonomous or drones or autonomous cars uses deep learning algorithm. Chatbots uses deep learning algorithm. Facial recognition, image colorization. Okay, you would have seen that the classical movies, the black and white movies, are getting colorized. Okay, so that is image colorization. Okay, so you would have seen the traditional black and white movies are now coming with colors. Okay. So they use deep learning algorithm. Medicines and pharmaceutical industries use deep learning algorithm. Personalized shopping and entertainment, they are more popular with deep learning. So this is now we have defined machine learning, deep learning, data mining. Now we see the complete structure of the artificial intelligence, and we can identify where our algorithms are, where this learning is happening. Okay, so artificial intelligence is the larger structure under which we have symbolic learning and pattern recognition. So wherever I need to identify a pattern or to recognize a pattern, when my application is about pattern recognition, immediately I need to come to machine learning algorithm. If it is about symbolic learning, okay, then I need to get into robotics or computer vision, okay, which is again an application of AI. If it is a pattern recognition, then immediately I need to come to machine learning. So under machine learning, we have two types. There is statistical learning and deep learning. That's why I defined all those in the previous slides. What is statistical learning? What is machine learning? What is deep learning? What is the use of data mining? Why I have not included data mining here? Okay. So machine learning has statistical learning and deep learning. So statistical learning requires text mining, which is again an application of data mining, speech recognition, and NLP. Okay, so these are the statistical learning. And deep learning. Under deep learning, we have three important algorithms: ANN, RNN, CNN. Most popularly used is CNN, which is computer vision, which is used for object detection. So this is the larger structure which you can visualize. Why somewhere there may be some confusion why machine learning is, someone will start with the machine learning and go to artificial intelligence. So it is not like that. AI is a larger structure because it is about human intelligence. Artificial intelligence is about human intelligence. It is a larger structure. It means that you are trying to create a human ability, or you are trying to bring in the intelligence which is capable of a human. Okay, so that is at the larger structure, that is artificial intelligence. In that artificial intelligence, the learning is done by if you want to create a learning, then the substructure that is required to learn is the machine learning. Okay, so machine is learning from the data input. Based on the learning, it is going to give you the predictions or the insights that can be drawn from the learning. So what is the need for machine learning? Okay, so everyone will ask this question: why today everywhere the machine learning algorithm is finding its application? Why or how it became so popular? Okay, that is because of these three revolution which happened. One is the cloud technology or the cloud data. Second one is the Internet of Things, which is which is the which is change, or which has brought the change into these technological revolutions. The industry 4 uses or embeds the IoT and the social media, the more usage of social media. Okay, so are these three have brought in the requirement or need for machine learning algorithm. Why? Because the amount of data that these platforms or technologies are generating is huge. Okay? The data that is generating is huge. So compared to 2000, if I start from 2000 to 2021, okay, the 20 years what we see, okay, there is a drastic change in the technology. The microprocessor, the processor technology has changed. It has brought down the processor capacity to a nanometer scale, and most of the applications now are smart. Most of the applications can communicate because they can connect to any of the wireless technologies. They can have wireless technologies within the smaller devices also. So the technology has shrunk, and the price that was the cost that was involved for purchasing those, or the cost involved for those devices, are also reduced comparatively. So it means that more and more devices are now used. So in your house only, if you compare 5 years back to today, most of the devices are embedded. Most of the devices are embedded. Your washing machine, your TV, your mobile phones, to any of the devices, they are all smart because they can communicate. They are connected to internet. They can once they are connected to internet, they will start sharing the data on the internet. So the popularity of machine learning, or the need for, I don't call it as popularity, the need for machine learning comes because of these three things. Because the social media, everyone is now connected to social media, and they are generating lots of data. Every second, if you see, 1.7 MB of data is created. Every second, 1.7 MB of data is created. And there is around 2.5 quintillion bytes of data are created every single day. Every single day, you are creating 2.5 quintillion bytes of data, which is, I cannot imagine, but it means that there is a huge data. We call it as big data, or there is a huge data that is created every day because of IoT. Because IoT means every device became smart, and every device has got connectivity to internet, and they can send and receive data. So even the washing machine can send and receive data. Even TV can send and receive data, because TV also now became smart and it is connected to internet. So it means that it is also sending and receiving data. And even the cloud, the data is coming to cloud from the IoT devices, from the social media, from industries, because even the industries also became smart because the machines now can communicate among themselves. That's where the cyber physical system was defined in the previous slide. Even the machines can communicate. The arrow marks indicate that they are connected wirelessly. So it means that from machine to machine there is a data transfer. From one machine to another machine to another machine, there is a transfer of data, and they are all connected to internet. It means that there is a large amount of data that is generated every day. My program, which I can write, I cannot imagine writing a program to solve this problem. So what we do is we come to what is called as machine learning, where the machine will learn based on the data, and it tries to draw the data. Tries to draw the patterns from the data, and which can add value to the businesses. Okay. For example, social medias like Facebook, they will collect your data, number of likes, and that is getting stored to cloud. From the cloud, the Facebook may collect your number of likes, maybe start recommending something else. Okay, so it means that it is adding business. Okay, it is adding business to that. data which was collected. Earlier, the data was not so, they were not connected. Data was also not connected. Data were independent and they used to analyze it as discrete. But now all the data are getting connected. From data, you are getting information. From information, you are converting into knowledge. Knowledge is getting into wisdom. And wisdom, from wisdom, you are drawing the insights. Okay, so this is the DIKW model, which is more popularly applied in machine learning or businesses to draw insights from the raw data. So the need for machine learning is, there is huge amount of data that is generated every day. Every single second also there is a huge amount of data that is generated. And all these data are getting stored in cloud. If I don't use those data, it does not have any meaning if I don't use the data. So now what the businesses are doing is they are connecting to cloud. From the cloud platform, they are drawing the data and converting that into insights. Insights are the informations from which they can predict the future, or they can predict what actions that can be taken based on the feedbacks that they received from the social media or other sites. So this is the need for machine learning. Then this is how we look after the data comes to the cloud, what better or what we can do. So there is an increase in generation of data. There is a large amount of data here, and that is getting into the machine learning algorithm. Okay, so what is the purpose of machine learning algorithm? It has to draw the insights from the data, like the number of sales which happened in that day, or number of sales that can happen in next week. So that is the decision making support. Or it can help you to uncover patterns or trends in the data. Okay, it can also help you to analyze the weather predictions. If you want to do weather predictions, it can also, based on the patterns within the data, it can give you the trend that today it is 25 degrees, tomorrow it will be 30 degrees, 35 degrees, so next hour it will be 45 degrees. So it is trying to uncover the patterns within the data. Based on the previous data, it is going to predict the new data. So that's where the weather reports are coming. And it is also helping you to solve some complex programs. So this is where the machine learning or machine learning is very essential and required. So who is the author? Who is the father who has coined this machine learning algorithm? Is Arthur Samuel in 1959. You can see that in 1959 only machine learning was there. Today it is more popular. But it was coined in 1959. Sir Arthur Samuel was the first to coin this machine learning algorithm. In 1956, the AI first was AI. After that, machine learning came into picture. So in 1959, Arthur Samuel coined machine learning algorithm. So what will be the definition for machine learning? Okay, so based on what was used in the previous applications, we can define machine learning as a subset of artificial intelligence, where the machines can learn on their own. Here the machines can learn on their own, and based on the learning, they can improve. They can improve the experience, and they can give a better efficiency compared to the previous experience, what they had earlier acquired, and they don't need to get programmed. They don't. These machine learning algorithms are not programmable. It's not a program. Machine learning algorithm is a algorithm which learns on its own, and based on the learning, it improves. It is continuous improvement. Okay, it goes on, keeps on improving based on the learning. So these are the 4 stages for a machine learning algorithm. First is the input. Important is the input that comes from data. That is the data that is fed to the machine, which is a computer system now. That is where the algorithm is running. So the algorithm, for the algorithm, there is a training data. The data which is coming inside itself is a training data for it. So it tries to, it gets trained from the data input to the machine, and the trained algorithm is called as model. A trained algorithm is called as a model. So the next phase of the training the machine is the building the model. Okay, so that is your model which you have created. Then once you have a trained model, then uh, that you can use it for predictions. Now you can feed any input to that, required input to that, not any input, required input to that for predicting. Okay, so you can use that independently, separately for generating the or predicting the outcomes. Just check the time. Oh, I'll just conclude with the algorithm because the continuation will be done by Jitendra sir. Jitendra sir, you are there? Jitendra sir? Okay, so these are the types. I just skipped because need to. So these are the three important types of algorithms that are used in machine learning. It is a regression based, classification based, or a clustering based. So these are the three important. This you need to remember, or you can just make a note that when I'm going to use regression based algorithm, when I'm going to make use of classification based algorithm, when I'm going to use clustering algorithm. Okay. So the regression is a supervised learning. In supervised learning, we feed the data which is labeled. The data is labeled. When the data is labeled, we use the regression, which is a supervised learning algorithm. So the output of this regression algorithm is a continuous quantity. Okay, so this is very important. I will underline this because based on this only, I'm going to decide which algorithm I'm going to use for training the model. Okay. So the output of regression algorithm is continuous. So this I'm underlining. This is very important. Wherever the output is, whenever I say that my output is continuous, then immediately you need to come to regression algorithm. Okay, I'm using regression algorithm. If I say that my output is continuous, then immediately I need to say I'm going to use the regression based algorithm. So what is the main aim of the regression based algorithm is a forecast of prediction. Okay, like stock market prediction. Okay, so you want to predict for future, then I use regression based algorithm. Okay, so one is output is continuous, then wherever you want to forecast or predict, immediately you say I use regression algorithm. Okay, so one of the example is linear regression algorithm. Then I have the second algorithm, that is a classification based, which is also a supervised learning. Again, supervised learning means the data is labeled. Okay, so then here the output is a categorical output. Okay, so either this or that. Okay, so yes or no, true or false. Okay, if the output is true or false, or yes or no, then what I have to do is, based on my output, I will decide. Okay, my output is a categorical output, so the algorithm that I'm going to use is a classification based. It is a classification based. So here, what is the purpose is, the main aim of this is to categorize the data. Okay, so for example, it is a spam or not a spam. Yes, it is a spam. No, it is not a spam. So there is only two options: either yes or no, it is a spam or not a spam. So then, which is the algorithm that I'm going to use? Classification based. It's a classification based problem, and I'm going to use classification based algorithm. And the algorithm that is most popularly used is logistic regression. And the third one is the clustering, which is an unsupervised learning. It means that in unsupervised learning, the input data is not labeled. Okay, input data is not labeled. It means that the machine has to learn. Here the learning happens because it does not know what is the input that is fed to it. In supervised learning, the algorithm knows what input is coming to it. So it's also knowing what is the output, expected output also, because based on the labeling. labeling will indicate what it is. So it knows what is the input and what is the expected output. But in clustering, it is an unsupervised learning, which is a which has to learn. The algorithm has to learn from the input. It has to do a feature extraction. It has to do feature analysis. Based on the feature, it has to analyze the features and then decide, okay, it is a particular output or not. Okay. So here the clustering, it is trying to group up a few related objects to form a cluster. So here the algorithm that is used is K-means algorithm for clustering. So based on this, now let us try to take few examples which algorithm can be used for these applications. Okay. So if I want to predict the price of the petrol and diesel today, okay. So because price of the petrol or diesel is a continuous, price is a continuous value. So whenever there is a continuous value, that is the output is continuous, then immediately which algorithm I have to use? Because it is a continuous quantity, the output is a continuous. So immediately I need to go for, because I need to predict the price, correct? So I need to predict the price. So the purpose is to predict the price. So immediately which algorithm I'm going to use? Regression algorithm. So whether to construct the house in a particular locality or not, yes or no, is the output. So immediately, if there is two options, that is either yes or no, approve or not approve, okay, then immediately it is a classification problem. If it is a classification problem, then logistic regression will be used. And based on the previous experience, I want to group up popular movies and non-popular movies, like in Netflix or Amazon. It groups up popular movies and non-popular movies. So it means that some few movies are grouped up as popular movies, few are grouped up as non-popular movies. So it means that it forms a cluster. It forms a cluster. So for the clustering problem where the clusters are created, so I'll use cluster-based algorithm, that is K-means algorithm. So I will stop here. So this is how you decide which algorithm you are going to use for a particular application. So if you have any doubts, can answer. Just Jitendra sir, you are there? Okay. Hello, madam. Deepa, madam.
Yes, sir.
That's it from my side, madam.
Okay. Thank you, sir, for a wonderful introduction on machine learning. Now we can break for 5 minutes, and you can come back for the next session by 11:50. Feedback link is for this session is posted in the chat box. Please fill the feedback form. Yeah. Um, Jitendra sir.
Yes, ma'am. Good morning.
Good morning, sir. So now I request Ms. Shruti to introduce speaker. Over to you, Shruti.
Good morning, everyone. We now have Dr. Jitendra Prasad with us. He has done his BTech in Computer Science and Engineering in 2008, a diploma course in Advanced Computing in 2009 from Sunbeam Institute of Technology, MTech in Operations Research in 2013 from NIT Durgapur, PhD in the year 2019 from VIT Vellore, where he performed research as statistical and machine learning approaches in share market prices forecasting. He has 13 papers published in national and international journals. He is currently working in Jane deemed to be university as an assistant professor, and so far he has conducted classes on Python and R programming languages, machine learning, deep learning, sampling methods, inferential statistics, and fuzzy logics. We welcome you, sir.
Thank you, Shruti. Uh, my name is Jitendra Jaiswal, not Prasad. Prasad is no Dr. Prasad from Tamil Nadu. Okay, no problem. Here all students are on only, so no problem. Almost everyone knows me. third year student, and second year students are here, along with MTech. MTech also, no? MTech students are also there. Yeah, MTech students are also there. Okay. So, okay, we'll continue with our session. Just a small like introduction or just information to me. Anyone just can tell me what are the points Narayan Swami sir covered today, so that we will be connecting those things. Anyone of you? Akansha, Abhinav, you're there?
Students, please respond.
Yes, sir.
Yeah, Akansha, that just you can tell me what Narayan Swami sir like covered. What are those topics? The basics of machine learning he covered, just a small introduction, like no supervised unsupervised learning you studied,
Yes, sir.
and some other points. What don't remember? Types of machine learning basics. In machine learning basics, what did you study? Okay, so I'll be continuing with my portion, what we had planned to continue with. So we will be talking today mostly about classification. Okay, so anyone just like no some question answer in the starting, so that I can know you know something about it, and in that way I can continue. Classification. What is classification? Anyone just can tell me? Well, morning session only you got tired. This whole day you are, it's there to study now by you. Categorical DVD. Yes, good, nice answer. That is correct also. Okay, so we'll be continuing from here. I share the screen also, and I share my whole screen. And we continue that. Screen and continue. So basically, let us start with the. So let's say, just 1 second. So, like, yeah, I'm properly audible now? Just anyone can respond, please.
Yes,
Yes,
sir.
sir.
Okay, thank you. So, like being data scientist, we will be talking everything about data only. Okay. So data, what is data? Data is basically collection of facts. Okay, facts about anything. So, but here in the data science and mostly in the machine learning things, we will be talking data in the either text format. There are number of data format over there, that is .txt format. Okay. Uh, .txt format are there. Little bit we have to manage, so just for explanation our exploration, elaboration, I'll be using this whiteboard, and with the whiteboard I'm not having digital pen, so we'll be managing with this only. So .txt and from the data we can have in Excel format. Okay, so .xlsx, or in CSV format also we can have. Okay, and data different other data formats are JSON format, CSS format are there. Okay, so number of format are there. So whenever we are talking about data, so data will be uh, first we will start with the data. How basically in how many types we can divide the data? Two types of data we can divide. Okay, one is quantitative. I'll just writing short point here, quantitative, because we will be I'll be telling those points what I'm explaining about. So quantitative and qualitative. Okay, so qualitative. So anyone can tell what is quantitative and what is qualitative? Just we can, if we can make it little interactive, no, so the session will also be not that much boring, and we can make it like we can continue it more effectively. Okay, so anyone just keep on responding. What is quantitative data and what is qualitative?
So quantitative is it can be measured, whereas qualitative it can be just viewed around characteristics.
Yes, that is categorical data. Here it will be based on the characteristics. Here it can be measured on numerical perspectives, no? Like on the numbers are the real numbers. Basically, it can be measured with the real numbers. Okay, that is what quantitative. So means the word, if you just little bit try to just like explore. So quantitative means quantity. Qualitative means quality, that is characteristics. So qualitative data, quantitative means here we can have quantitative data. Further two types. That is, one is called discrete. Okay, discrete, so that is called as the whole number data, means that is there on the basis of count. Okay, so that will be, that can be counted, and counted as a whole. Counted, obviously anything is being counted, so it can be counted as a whole number. Okay, and next one is another data is called as continuous data. Okay, so next data, continuous, means this is real number data. Okay, real number data just incorporates all type of data, that is whole number and decimal number, negative number, positive, negative decimal, positive decimal. All the numbers are being interpreted over here in continuous data. Okay, so discrete and continuous. Okay, qualitative data can also be further divided into number of divisions. Actually, this is based on the researchers. It is not like standardized key, only three types. We under three types only we can divide the data. Okay, qualitative means categorical data. It can be. Okay, so basically qualitative also sometimes called as categorical. Okay, so another data may be binomial. Okay, binomial. Another one is ordered data. Okay, ordered. Ordered means, let's say we are giving feedback or to anything, so it can be good, like very good, good, or then it can be moderate. It can be bad, no, bad. very bad, like that quality, we can use it. So that also is somewhat characteristics only. And sometimes this ordering may be on the number basis. Okay, so 0, we can give the ranking. So 0, 1, 2, 2, 3, something 4, 5. So 0 to 5, if we want to give that that is called as this one is sometimes also called as ordered data, and if we go more closely, it is called as scale data. Okay, scale data. So these type of division, I think you would have been knowing already. Okay, so next we will proceed with the data. So data, generally, whenever we talk about data, so what picture come into your mind? Anyone? Like anytime if I say about data, so what picture come into your mind? It is mostly on the tabular format. So data will be like there is one more perspective of the data in the context of big data analysis. That is in that perspective, or in that context, we can say data may be divided into what structured, unstructured, and semi-structured data. So here in machine learning, mostly we will be talking about structured data. Okay, here in the context of a natural language processing, NLP, and means voice processing, there we can say we can deal with unstructured data also. Okay, so there in that context, it is structured and unstructured, but mostly here whenever we will be talking about the data, it would be on tabular format. Sometimes it may be in the text format, but again, when we are going to work on this data, so we will be trying it to convert into tabular format. Okay, so these tabular format also can have data in different types of data. Means it may have some this table. Basically, this table is having, let's say, some data is there. Okay, so this table means it will be expressed in the row and column format. Okay, so these are the columns. So here we can have variables. Okay, and these are the rows. These rows means rows. Here we will be having observation of the data. Okay, observation means sometimes in some word it may sometimes called as entities also. So these are called as variables. Okay, variables, or sometimes this is called as attributes. Attributes, or any more word anyone can say? Variable, attribute. Okay, so these are generally these are called as variables are attributes. Okay, so these variables also can have some variable as quantitative data and some variable as qualitative data. Okay, so this variable the next point come into the picture whenever we are talking about data. So these things, no, for the data perspective, is quite important. Many a times, many students are confused. What is variable? What are attributes? And when come inside it inside the data, again more next step, then these variables may be divided into independent variable and dependent variables. Okay, so in the context of classification and regression, we will be talking about. Okay, but in the context of classification, we will be dividing these variables in the form of independent variable and dependent variable. Okay, some more terms are there. Anyone can say? See, these are very small and basic things, but many a times many students lags. Okay, those who are knowing well and good, but many of you sometimes may be lagging, because this complete picture should be there in your mind. And whenever we talk about the classification thing, this whole data, the picture of whole data should be coming into your mind. Okay, so coming into your acknowledgement. Okay, so in the context of when we talk about the regression and classification perspectives, so we can divide data into dependent and independent variables. When we talk about clustering perspectives, okay, so we will consider whole data. I mean, all the variables as a whole. Okay, based on the characteristics of all the variables, we will be just making clusters, different clusters based on the data. Okay, so when we are talking about in the context of regression and classification, we will divide the data into independent variables and dependent variables. Sometimes we say that predictor variables, okay, predictor and response variable. Okay, just to do, again, I'm telling, don't go on my writing. I'm just writing it to make a little bit sense, because here you may not be able to read what has been written. The variable, it is attribute. So here we are talking about either it may be considered as data can be segregated into independent variable or dependent variable, independent variable and dependent variable. Sometimes these are called as predictor variables, are response variable. So response variable is nothing but the dependent variable. Predictor variables are nothing but the independent variable. These are just synonyms, are just different technical terms, what we say over here for these data. Okay, so whenever we talk about the classification things. Okay, so classification basically we can decide whether we are going to apply classification techniques on this data, or we are going to apply regression technique on this data. So what can be the characteristics where we can apply the classification on this data? Should I take your name? At least you keep on just interacting, or so it will be quite easy now. Quite good. Sanjeev, can you say? What did I say? Yes. In the classification perspective, how in what type of data we can apply the classification, and what type of data we can apply the regression. Okay. So, yeah, at least third year students are quite responsive. They respond very well. No one is responding, and you guys have studied these things quite explained with. So at least you can participate now, so your juniors can understand about it. Secondary students can understand about it in a very good way. Okay, so when we talk about classification, so when our data is in the form of data is in what categorical form, okay, categorical or qualitative, no? Basically I should write qualitative or categorical. Okay, qualitative, then we will apply classification. So not whole data means when this is based on our dependent and dependent variable. When our dependent variable, mostly we represent dependent variable as the last variable in the data, but it is not at all necessary. You can put anywhere. Mostly it is being put on the last column of the data. Sometimes it can be put on the first column of data or second column of data. So it depends on the cases. Okay, so based on different cases, like now based on the data availability, we can select whether which data is our dependent variable or response variable. Okay, so when our dependent variable or response variable is categorical, okay, so it is we will be applying classification. When our response variable is quantitative. Quantitative means we will quantitative obviously means real numbers. Okay, so discrete and continuous data are sometimes called as collectively are called as continuous only, because continuous data can incorporate or can include numbers as well as decimal points. So we generally sometimes say that this is continuous data, or we can say the real data. So when it is real data, obviously we will be talking about regression, or we will be applying regression techniques. Okay. Now when yes, classification and regression thing, one more are considered in one more perspective, that is called as supervised learning. As a machine learning, we discussed, you have been you have been studied like Naran Swami sir would have explained supervised and unsupervised learning. Okay, so unsupervised learning. So this classification and regression comes under supervised learning. Okay, and clustering, basically clustering comes under unsupervised learning. Correct, no? So anywhere, if you are finding any difficulty anytime, you just let me know at the same moment, so that we can discuss on that point. Okay, and we can make your confusion remove. Okay, so now this is what classification and regression. So it would be applied. These techniques, classification techniques and regression techniques, they are different machine learning algorithms for classification and regression techniques. So these like these techniques comes under supervised learning, and clustering thing comes under supervised unsupervised learning. So again, when we talk about in the data, when we talk about the independent variables and dependent variables. So when dependent variable is categorical data, so we will be applying classification. When dependent variable is quantitative or numerical data or continuous data, we can apply regression. Okay, so here we can understand that what are those points. First one is data. Data are different types. Okay. Qualitative and quantitative data types. Then machine learning types. Okay, machine learning are supervised learning and unsupervised learning, and one more learning comes into the picture, that is basically hybridization of supervised and unsupervised learning, that is called as a reinforcement learning. Okay, so these are like some as I told, these divisions, no, I told in the case of categorical data also, some researchers may consider it as 4 type of categorical data, some researcher may consider it as 5 type of categorical data, some researchers may consider it in 3 types of categorical data also. Okay, means if they make little distinction or difference between the like explanation, they can just give the different name for it, or they can make it as differently categorized. Okay, so reinforcement learning, basically some of you your third year students, you would be knowing, even secondary students, those who have been studying machine learning, they also would be knowing. Reinforcement learning is basically reward and punishment. Okay, when it is correctly classifying or correct, it is predicting in the correct way, so we will be rewarding it. And it is, if it is predicting in negative way, means wrong way, so we will punish means we will award minus point to it. Okay, so that based on the positive points, it may improve gradually. Correct, no? So there's supervised learning and unsupervised learning and reinforcement learning. Some researchers again make some another type of machine learning, that is called as semi-supervised learning. Okay, semi-supervised. Semi means the partial or half, we can say. So half of the data may go for the supervised learning, and later it may include unsupervised learning also. Okay, so we just hybridization of supervised and unsupervised learning will be carried out in these two different perspectives. Mostly it may be carried out in unsupervised learning and reinforcement learning, as it is based on the reward and punishment technique. Okay, so uh, real time example for supervised learning. Anyway, I think Narayan sir would have explained about it, supervised and unsupervised learning. I will also tell, just take one example of the real life. Okay, not real time, real life. Okay, so real life means supervised learning is basically is considered as one. It is, this learning is carried out in the supervision of someone. Okay, supervision of someone means if you just ask, if there is someone to supervise you, okay, for making you learn, okay, then if you ask what is this, he will tell, this one is apple. Okay, or anything means he will tell, for example, this is apple. If you ask what is this, then next time it can, he or she can, or it can tell you this is apple or banana or another thing, or this is some tree, or this is. So these are based on what supervised learning. So like no, our supervised learning can be considered in the any stage of our life. Okay, whenever when you are not knowing anything, let's say on this stage when you are not knowing about anything, if you ask about it someone, okay, what is this, what is it called, so he or she can tell you that this is this. Okay, so that is called as supervised learning. And unsupervised learning perspective may be like, no, when you are very newly born kid. Okay, newly born means like toddler or just a small kid only, and who is wondering about everything. What is this, what is this, what is this, and if there is no one to tell anything about it, then he will be just observing the characteristics of those things. Okay, okay, this is something round shape, and this is something long shape. So this is one type of fruit. This one another type of, this may be apple, this may be banana, but obviously here names are not given. So it may write category 1, this is category 2, another fruit, or as we are talking in the context of fruit perspective only. So it may be considered that this one is another fruit, like let's say orange or something. So based on the category, it will be categorizing. This is category 1, category 2, category 3. So this is called as clustering. So that is called as unsupervised learning. So these learning also is basically a long term of uh, uh, perspective. Like we also being human being, we have also learned about different things. Okay, in very long time. Okay, like we are in the sufficient age of the human being, so we have learned about many things. So we can say these are this, these are this, these are this. But the same way the machine also has to learn. Okay, so as this we can say that machine learning things came into the picture very recently, let's say last 10 20 years. So machine also has to learn a lot. Okay, so these type of learning that is being carried out for the machine is called as machine learning. Okay, so these are the these are for the learning perspective. So these are learning, classification, regression, and data. Now we will again come back to the data. Okay, one more important thing is, okay, we will again come back to the data. As we have talked, data will be in the perspectives of when we talk about either classification and regression. So we will divide variables into independent variables and dependent variables. Okay, so either we can say that predictor variable or response variable also. So at that time, how we will decide that we will be applying classification and regression. So that is basically based on the our dependent variable. So this dependent variable is if it is numerical type, numerical data. So obviously this is continuous data. If this is continuous data, we will be applying regression. So when it is categorical data, so at that time some more technical terms are used. We say it as, when it is categorical data, we say it as we say it also as labeled data. Okay, labeled data. Labeled data means the data has been labeled. So in what way this can be labeled? Like if it is binary data only, so it may have a value as yes, no. Okay, for anything as no, then no, these type of values it will be having. So that is called as labeled data. Okay, sometimes it may have this labeled data when we are going to work with. So this label data may be sometimes converted to 0 and 1 numbers. Okay, if we want to convert it in 0 and 1, are like we can give the factor to this label. Okay, let's say it is not necessary that the data will be only binary. It may be there may be more than two labels for the data. So when there are two labels only, that is called binary data. Okay, when it is more than two labels, so it can be multiple label data. Okay, so at that time when we want to convert it into numerical format, numerical values, so we will be factorizing this. Let's say it is male or female. Okay, so male may be given as 0 or 1, female may be given as the 1 or 0, or if it is yes or no, yes or no, so yes may be given as 0 or 1, and no can be given as 1 or 0. So if it is more than two values, let's say it is good, bad, and moderate. So you can give good as 0, bad as 1, moderate as 2, or if you want to start from the 1 itself, so you can give good as 1, bad as 2, moderate as 3. So and continue. These some chats are here. Continuous quantity, obviously for regression, quantitative regression, qualitative classification. Yeah. You can respond, means like you can if your mic is working, you can talk, no, talk over it. So these are what we are talking about, labeled data. Okay, so when data is in categorical format, so we can call it labeled data. Sometimes it is also called as class data. Okay, class data. So these are some terms which make us sometimes when we are very new to this data machine learning and data things, it is very sometimes it is very confusing. What is labeled, what is class data? So class labeled data is sometimes also called as class data. Okay, it is not different than labeled data and class data are not different. Okay, so when it is labeled data, obviously we will be applying the classification techniques. When it is the continuous data, we will be applying the regression techniques. So for classification perspectives, these are the main points. These points are like, it may appear as very easy, but no, when obviously even when you can recall that when you were quite new to these things, these were also we were finding so much difficulties. Okay, so what are dependent and independent data? So in the context of let's say regression, how we will be representing in the context of regression. So generally we will apply, let's say y is equal to a naught plus a1 x1 plus a2 x2. Basically this is the one example of regression, that is a linear regression, a2 x2 and so on. So this is regression. So at that time, see here the y can be considered as dependent variable, and these values x1, x2 and so on, x3, these are called as independent variable. Independent variables, these are independent variables, and obviously there are different terms also for these variables. This can be called as response variable, and these can be called as predictor variable. Some more terms are also there. Anyone remember? I'm just the predictor variable. Okay, so some more terms may be used by different researchers are there. The response, predictor, dependent, independent, and in that way. So here in these equations, you can find out, okay, this one is called as regression. In the context of regression, that is linear regression also. These are what? Independent variable. These are independent variable, and this a naught, a1, a2 are called as coefficients. So that is basically from the perspective of regression. So when we'll be talking about regression, so today we will be talking about mostly about classification only. Regression, the concept of regression, we will be not elaborating so much on it, just the equation, and if time permits, we can go for some like no when you see the implementation of classification things in the let's say in the Python or with the different machine learning techniques, different algorithms. So it's the same way you can continue the regression things. So classification things we will be looking as practically implemented, and regression things we will be mostly talking in the theoretical aspects. Okay, so these are the basic terms that are coming from which are let's say classification and regression, and the clustering thing is there for the unsupervised learning. So unsupervised learning also we will not be talking much about it. In the today class we will be talking about the classification things. Okay, so classification things means what is classification? So when we are having some data, okay, let's say we are having some data. Again, every time we will be talking about data only. We'll be talking through the data only. Okay, so let's say some example. Any data we can just call. So let's say credit card. Okay, so whether someone will be buying a credit card or not. Okay, credit card data. Okay, so credit card means the one variable may be gender. Okay, so gender, it may be either male, female, and the female, some more value. Okay, just the means demo purpose we are done. Then what can another variable may be contributing there? That can be age. Okay, so age may be, let's say, 26, 35, 39. So this age has to be in the continuous data format. Then another thing is whether its salary is quite important. Salary. So let's say salary here 30K, salary in thousands. So 30,000, let's say 45,000 here, let's say is 50,000. This one is 32,000. Okay, so salary also has to be in numerical data or continuous values. And next maybe whether he is already having a credit card or not. Okay, so one variable may also be contributing, so that is already having card. Okay, so let's say yes, it may be, let's say yes, it may be no. Okay, so now whether he will be buying, he or she will be buying next credit card or not. So this will be purchase or not purchase. Okay, so for purchase we can say yes, for not purchase we can say no. So let's say he's not having already a credit card, but he may buy new credit card. He's having, then he may not buy credit card. He's not having, but still they may not have, they may not buy a credit card. Okay, so this is what our dummy data we are having. Okay, so why I'm calling these data, because we are going to talk about the classification. Okay, so in what way we will be classifying? So this is our, let's say, let us consider whether the person will be buying, purchasing new credit card or not. So based on it's a purchasing and not purchasing, we will be classifying the data. So here we can see these two are there for the classification, for the buying credit card, and these two are there for not buying credit card. So obviously when our data is quite small, so we can say that we are classifying data for these two values, whether it is going to buy and not going to buy. Okay, so once we have there are two perspectives again. So based on data, once we are having data, so for applying data, okay, applying machine learning technique on it, we will be dividing our data into two perspectives. What is called, one is called as training, okay, and another one is called as testing. So training data, we will be dividing our data into training and testing perspective. So it is mostly called in the context of machine learning things are that as much data as we provide to the machine, it will be that much effectively trained. This is common general sentence, but it is not going to correct, not going to correct always. Okay, sometimes you can give more data to the machine, so it may be overtrained, or at that time it is another term comes for it, that is overfitting. Overfitting has some other characteristics also that we will be talking about. And when there is quite less data, so at that time it may be called as underfitting. Okay, so machine may not be, or our machine may not be trained up to that much effective. Okay, so this is called as training and testing perspective. Okay, so there are different methods for segregating training and testing. Okay, these things comes under let's say cross validation technique. Okay, where we are having different segregation, different way of training and testing, and we try to measure the performance of algorithm on that data. But generally we segregate our data. uh, One more term comes as cross validation. So cross validation basically comes maybe just a small explanation I will be talking about here for cross validation. Cross validation basically, it comes already we have performed with training and testing. So now we will be just changing the mode of input. Okay, and we will again try to improve the performance of that algorithm that is being applied on the data. Okay, so that is called as cross validation. Cross validation we'll talk more about it. But here initially when we are segregating data into training and testing perspective, so generally we can put 75% data for training and 25% data for testing. Sometimes we can have 80% data for training. So here it can be considered as 20% data for the remaining data will be going for testing only. Okay, sometimes we may have 70% data for, we may give the 70% data for training. So obviously 30% data will be there for testing. Okay, so generally these three belts are being considered for training and testing. Okay, so what is basically training and testing? So how we can find, how we will be applying training and testing on this data? So what variables will be going for training and what variables would be going for the testing? Okay, so training, let's say 75% data we are segregating for training, So in the training, these four variables will be considered as dependent variable. This one is called as independent variable, or these four variables may be also termed as response, what predictor variable and response variable. Okay, so when our machine will ask if person is male, his age is 23, 26, and salary is 30,000, and he is already a credit card. So whether the person will be buying a new credit card or not. So based this data is nothing but the past data, history of data, past data, or it may be considered as data from the different people which has been collected from the different person. Okay, so machine will observe here that based on this he is going to buy the credit card. Again, based on these observation, he is again going to buy the credit card. Based on these observation, again he is going to buy the credit card. So in training, these all variables will be participating. What will happen in the testing? Okay, so in testing, here we based on these values we will be predicting. Okay, and we will be predicting. So let's say based on these value we predicted as he will be buying the credit card. But here actual, this is called as actual data. So actually she has not bought, she has not bought the she did not bought the, sorry, did not buy the new credit card. So what happened here, our prediction go wrong. Okay, so it is not like that only one data we will be having for testing. Obviously 25% data we will be having for testing. So most of the time we may predict correctly, and sometimes we may not predict correctly. Okay, so in that way, how shall we be analyzing how much accurately we are being able to predict the data? So those things comes under true positive, false positive, true negative, false negative perspectives. Means those are the measurement techniques that are how much effectively we are being able to predict predict about the data. So up to this, I think everyone is following. Any question? Anyone has any question? We talked about, let's say, data, categorical data, means different type of data, then different machine learning techniques. And in this data, we talked about the this way. This is going for when we are having categorical data in our response variable. So we will be applying the classification techniques when we'll be having when we are having this continuous data in our predictor in our response variable. We will be applying the what regression techniques. Okay, so just for observation, we can just one more example we can take the whether we will be applying regression or classification. So based on some variable, let's say here we are getting some value. The person bought for the amount 2500. Someone bought for 1955. So someone bought for 2555. So let's say it is the a person who is coming to a retail outlet. How much shopping he or she is doing. So person with it may be male, female, or it may be female. So it depends on its their age 26, 20, let's say 29, 35. So based on his budget, or based on the choice brand name, he based on, let's say, if it is Nike, it is Reebok, it is again Pila. Okay, so it is another these other constraints are there. So collectively, how much amount he is going to spend on this shop. So let's say the person bought for, let's say, 2500 rupees. Another person bought for 1955 rupees. So here, any person who is coming, it is not necessary that he will be buying with just with some numbers only, let's say 1000 or 2000. It may vary on any value. So here we can apply the regression techniques. Okay, so these are for the regression techniques and classification techniques. In the classification techniques for this true positive, false positive and all, we will be talking while the calculating, while implementing the concepts. Correct. So next we will move. I think some let's say what point we are having. Some more points for the classification. We are having these points. Is what we had talked about. Then this classification and regression techniques comes under supervised learning technique. Okay. Next, the number of classification techniques are there. Naive based. Naive based will be based on this Bayesian theorem. Okay, we will be talking about it while implementation. Okay, so next we are going to take some example and we will be implementing these things so that on real-time basis and with some real data or on some dummy data we can apply these techniques. Another technique is decision tree that also comes under classification. Okay, then here the decision tree, then k nearest neighbor method also is there for classification. Okay, and this is for k nearest neighbor, and then holdout method is for the training and testing perspectives. Okay, so basically holdout is for training and testing. We just divide the data into training and testing set. Okay, so we can go for 70 to 80% data for training and testing. And yeah, one more point again here was that sometimes some researchers may also include one more perspective. Okay, it is called as validation. Okay, so it is somewhat related to testing only, but sometimes some researcher may divide the data, let's say 30%, 70% for training, 25% or 20% for testing, and let's say 10% they may go with for the validation. Means again they will be validating whether they are able to correctly predict or not. Okay, let's say 75% for training, then again 20% for testing, or 5% for validation. They may go for 80% training, then let's say 15% for testing if data is quite big. So 80% for training, 15% for testing, 5% for validation. So this one other perspective also some researchers apply for other than training and testing. But most of the researchers, they apply training and testing perspective. So once they are getting with the good training, okay, with good accuracy for the training and while testing the data, so they can say, okay, our model is now quite well trained, so it is now in the position for predicting about different perspectives. Okay. Okay, one more perspective is remaining, one more point is remaining, that is called as bias and variance. Okay, so bias is basically the difference between actual and predicted values. Okay, the how much effectively we can be able to predict the data, whether there are quite difference for predicted and actual data, or there are very less difference for predicted and actual data. So when that is there may be two perspectives, or basically we can see three perspectives. So when bias is quite high, okay, so at that time we can say means bias is quite high means obviously yeah, the difference between actual and predicted values are quite high. Okay, so at that time why these things happen? It may happen due to one of the reasons, that is called underfitting. Okay, underfitting means when our data is quite less trained, or it is going through the less number of, means not that much sufficient amount of data is being provided. So mm, the scenario of underfitting may come into the picture. Okay, here you can see here like model predictions we are having representing with the red line, and this green line is for actual value. So initially you can see that initially this one is it is having very less difference between model and like actual and predicted value, but later the difference is going to be gradually very high. Okay, so at that time we can see the prediction is quite much biased. Okay, so why it happens? Because it is there for the case of underfitting. Okay, but next, obviously, when the one term is there for underfitting, then another term will be coming as overfitting. So at that overfitting, in the context of overfitting, the next term comes as variance. Okay, so variance is basically you would have studied in the stat also. What is variance? So basically the deviation of the values from the mean values. Okay, mean values are being considered as our expected value. Okay, so whenever we are getting deviation, quite deviation from our mean value, that is called as variance. Okay, so here also we can say if we have more deviations from the actual and predicted value, so that case may be considered as the case of overfitting when variance is quite high. Okay, variance is quite high. So there when variance is quite high means we can say that let's say here when variance is quite high means let's say our data are like this, no, something, and when variance is quite high means this may sometimes it may go here, sometimes it may go here, sometimes like this. Okay, like this it may reflect our reflect our output. Okay, so when variance is quite high, it will be covering most of the points of the data. Okay, but at the same time, the difference between the actual and predicted values will be quite high. Okay, so that is that case comes as overfitting. Overfitting sometimes one reason for overfitting is that sometimes we may give abundance amount of data to the model. So sometimes it may also get overfitted. Okay, and next another point is that when it is having quite high variance, at that time also it may be the case of overfitting. Okay, so in the case of overfitting, you can see if when our data is uh, effectively predicted, so we can have our predicted curve like this. But when we are our data when there is quite high variance, so at that time we can have our fitting value like this. Okay, and the difference between these values from the actual to predicted will be quite high. So this is the case of high variance. Okay, this is called as the case of overfitting data. Correct, no? So anyone sorry so far any question, anyone? Just one more theoretical aspect we will be talking about, then after 5 minutes or 5-10 minutes we will be moving for the implementation. Okay, so we'll be talking about key as we have further how we will be finding, how we will be calculating that how accurately we are going to classify the data. Okay, so what is happening over there, either means our data is in format, let's say the predicted value and the actual value. So there would be some difference. Okay. There may be some difference in the predicted and actual value. Let's say first is y, second is n, then y, y, n, and like this 3 3 6 2 8 then first one is y, then it is let's say again y, then it is n, then it is y, uh, y, then again y, then n is a let's say n and n. So this is our predicted value and this is our actual value. So there are difference in the like number of values are different. Let's see, here it is correctly predicted, here it is wrong, here it is wrong prediction, here it is correct prediction, correct, here it is wrong prediction, and here correct prediction and correct prediction. Okay, so how shall we be measuring this? So obviously these numbers are there for our concern, that how many values are correctly being predicted, how many values are wrongly being predicted. So in that context, four things comes into the picture. Okay, uh, that is called as true positive, okay, false positive, then obviously when true and false, then again true negative and false negative. So how shall we be finding these two contexts here? This is whether it is correctly predicted or not. When correctly predicted means it will be true. When not correctly predicted, it will be false. Okay, so these two cases are false when not correctly predicted. Okay, so true positive, false positive, true negative, false negative. So this one is predicted values. These are predicted values. So based on predicted value, we will be finding whether it is true positive or false positive or true negative or false negative. Okay, so this one is the actually with the actual value we will be tallying, but first we will be observing the predicted value. Correct now? So we will be first observing the predicted value. So here let's see one aspect we can considered as positive and another aspect we can consider as negative. Let's say here yes is obviously considered as positive, okay, and no is considered as negative. So this one is predicted and we have to focus on this with the predicted. Okay, one more point, that which one will be considered as positive and which one will be considered as negative. Whether yes will be considered as positive and no will be considered as negative. Sometimes it may be clear, like no, many people will say, okay, this perspective you can say as positive and this one is negative. But sometimes it may not be. Like no, if a person, if let's say credit card fraud detection. So if I categorize our data are fraud as fraud and non-fraud. Okay. So in that perspective, which one you will be using as fraud and which one you will be using as non-fraud. Okay. So if you consider this one as positive, okay. So but see, fraud is negative word. So you may consider it. Some researcher may consider it as negative word also. Correct? No. This one is non-fraud, and you are considering it as negative. Okay. But non-fraud word meaning is somewhere in positive sense. Okay. So some researcher may consider it as a positive perspective. Okay. So so in that case, what we should do? We have to mention that which one we are considering as positive and which one we are considering as negative. Okay. So here, as for yes, we are considering as positive. For no, we are considering as negative. Okay. So now, y is the predicted value, that is positive. So this one is here. This is positive, and whether it is correctly predicted or not correctly predicted means truly predicted or falsely predicted. So actual is same and predicted is same means it is case of true positive. Are you getting that? Here negative means it has to be n, no? And the matching is not there. Okay, so actually it was positive, but predicted as negative. So it is false negative. Okay, so y is positive p and n and y is there, then again false positive because actual was negative and predicted as positive. So it is false. So here y and y are positive. So it is true positive. Then again y and y are positive. So true positive. Okay. Uh, y and n, so it is a negative but false negative because not correctly predicted. Then n and n, so it is negative but correctly predicted as true negative. So and here n and n correctly predicted, so that is true negative. Okay, so in this context we create the confusion matrix. Okay, so how we will create the confusion matrix? So here we will be having four values. Here it is for the predicted values, and here are actual values. So predicted yes and predicted no, actual yes and actual no. So this one y and y means positive. So this is the case of positive means true positive. So this is true positive. Predicted negative means n but falsely, so false negative. Okay, here predicted y means positive but falsely predicted, so false positive. Predicted negative actually negative, so it is negative and true negative. So how many true positive cases are there? True positive 1, 2, 3, yeah, 3 are there. So true positive. False negative, how many are there? Fn1, Fn2, so two cases are there. Fn2. Okay. And Fp, Fp1, and anyone more FP? So Fp is equal to 1. True negative, how many? One true negative here, two, three, and three. So it is how many? 3, 3, 6, 2. So two cases. Tn is equal to. So these are the cases for this is called as confusion matrix. Here 2 cross 2 matrix we are finding. Okay. Sometimes it is based on the variable. When we are having only two values as binary data, so we are getting 2 cross 2 confusion matrix. When we are having three label data over there, means in the class we are having 3 labels. Okay, so you may get 3 cross 3 matrix. So this is called as confusion matrix. Okay, this is confusion matrix. Okay, so we will see there are some different terminologies for means this section data, that is called sensitivity or recall, specificity, then precision. Okay, and F1 score. A number of terms are there that we will be looking over there. Okay, so let us just some 2, 3 more minutes it will take. Okay. So sensitivity means number of just terminologies are being given over here for the different perspectives. Okay, so one is called as sensitivity. Okay, sensitivity means it is called as sensitivity or recall. It is also called as the recall. Here we will be looking that how in the positive perspectives how much accurately we are going to predict. So this is basically uh, Means for positive cases, how effectively we are predicting. So for total positive cases means truly positive. So it would be TP, true positive, and divided by true positive, what for what you have already predicted as positive. But there were some more positive data for which you had predicted negatively. Correct? No. So those positive data will also be there. So true negative. No. TP plus TN. So sorry, false negative. No. False negative. Because there are some data for which we have been uh, predicted as negative, but those data were positive. No, so we are considering all the positive data here in this case. So TP upon TP plus Fn, that is false negative. So what will be the value? TP is 3 and Fn is 2. So 3 upon 3 plus 2, 5. So that is called as 3 upon 3 plus 2, 5. So that is called as specificity. Sorry, sensitivity. This one is sensitivity or recall. So this is, let's say, 0.6. Next thing comes, as this is the case of positive all positive things, then there would be obviously some negative perspectives also. So this, as this is sensitivity, another term is called as specificity. So what can be specificity? Means total negative, means how much we have negative predicted correctly predicted negative cases. So Tn, and so Tn upon Tn plus, there would be some data for which we had predicted as positive, but actually they were negative. So when we had predicted as positive, so and actually they were negative, means false positive. False positive. Correct? No. So Tn upon Tn plus Tp, that is Tn means these two, and sorry, Tn upon Tn plus Fp we have to take. Tn upon Tn plus Fp this side. Okay, so 2 upon 2 plus 1, that is 2 by 3. This is 2 by. Next one more terms comes as the, what is next is called as precision. Okay, so precision is basically positive predicted value. Okay, all positive predicted means either we have wrongly predicted or correctly predicted, but all positive predicted value. So that is called as precision. So all positive means true positive. So that will be TP upon TP plus FP. Whether we have correctly positive, sorry, FP. So TP is equal to 2 and 2 upon 2 plus FP. How much? FP is 1, no? So FP is 1. So again it is going to come as 2 by 3. TP, sorry, TP how much? TP was 3 now. TP is 3 and TP is 3 plus FP is 1. So 3 upon 4. Okay, so this is called as precision. So next one more term come as F1 score. Sometimes it is called as F score also, and sometimes it is called as F1 score. So F1 score is nothing but the harmonic mean of precision and recall. Okay, harmonic mean of precision and recall. So this is precision, this is recall. So harmonic mean means 2 into precision, okay, into recall divided by precision plus recall. So it is 2 into precision and recall. What are the values? 0.6 and 0.75. No, this is 0.6, this is 0.75. So this is 0.6 and 0.75 divided by 0.6 plus 0.75. Okay. So that is called F1 is 4. So 6, this value we can calculate here, 2.6 to 75.75 into 2, that is 1.5, and 1569.0, so that is 0 0.9, 1.5 0.09 divided by this 6, so it's 13.5, 1.7613, 1.25. So that is F1 square. Okay. One more very important term comes into in this context. It is called as Matthews correlation coefficient. That is called MCC. Here it is considering all the values. Okay, that is Matthews correlation coefficient. So this is like no one important thing, and here it is considering all the. So this is TP into FN. Sorry, TP into TN means all correctly predicted values minus wrongly predicted. So FP into Fn and divided by under root, because this is square term now, so we have to take the here and here also we will be taking multiplication 4 times, so that is called as TPFP, means all the combination TP TP plus FP, TP plus FP multiplied by TP plus Fn, TP plus, means see these 4 corner values are there now. So this is TP, so with this and with this, so TP and FP, TP and Fn into with this negative value, so TN true negative TN and FP, TN and Fn, so TN and Fn, TN Fn into TN plus FP. So this, see, 4 terms are being multiplied, so the power is going to be 4. Take the square, so it is coming as a square term. Here upper side also square terms are there. Difference of square are square terms. So this is basically square term divided by square term. Okay, not 0. Square term divided by square term. So it will be coming some value between -1 and +1. It will be coming value between -1 and +1. And as much as it is going to be +1 side, that much effectively the result will be considered. Our result will be considered that much effectively, means as much as it is close to +1, we will say we are getting quite more classification, means more accuracy we are getting. Okay, so now it's already 1:15, so we will carry just I just explain some coding, okay, and rest all coding because of the time. These terms were quite important, so as we had to discuss all these basic things. So I think this conversation or this discussion or these all discussion would have made you understand or make your basic things quite clear, because already you may be knowing all these points, but like no, when we go quite deeper inside it, we make our concept more clear. Okay, so here we will be continuing with some practical implementation. So let's share with the code. We will be carrying out with Google Colab. So just some Python programming also we will be revising it over here, and along with that we will see how we can apply different classification techniques and regression technique also. We can time permits, up to what time we have to wind up, ma'am? Deepa ma'am, can you please tell me? Up to 1:30, I think, no? Half an hour they will get the lunch break.
Yes,
Anyone?
sir. Half an hour. Yeah.
Yeah. So it is just 20 minutes mostly we will take. Okay, so we can create some dummy data also for applying classification, or we can take some repository data also. So for creating dummy data, we can just create with the pandas. Okay, first we create number of variables, and with that number of variables we can pass it to the pandas, and that pandas will be making it to data.frame. In the with the data.frame you can create those variables, sorry, those data. Okay, so I have created one credit card data for that we had talked about. So people may have their user ID. Means I have just created dummy data for these 10 values. So this is one UID 1, UID 2, user ID, gender, male, female, like that. Age is numerical data, and estimated salary is this, and whether they are going to purchase a card or not. So if 0 not purchased is 1 may be purchased, or you can say 0 purchased, 1 not purchased, but you have to explicitly mention it over here. Okay, so number of some libraries may would be required over here. So obviously it's a basic library, pandas, numpy. Okay, and sklearn dot model selection. For that, from there we can get our training and testing data segregated. Okay, you can also manually segregate your data based on the indexing values. Considering indexing values, let's say you are having data rows from 1 to 100. So from basically the indexing in the Python is starts from 0. So 0 to, let's say, 75%, 0 to 99 will be the indexing for the data. Let's say if we are having 100 data, so you can consider first 75 rows if you are considering 75% data for training. So there you can consider the training data. So 0 to 74 for your training data, and then after from 75 to 100 it may go for the testing data. So when you can keep in mind when you are segregating data, so training data when you are segregating manually, so you will be considering both dependent and independent variable. Okay, so in that training data, for all the independent variable you can consider it as extreme, and one dependent variable that you can consider as Y train, because you are segregating this training and testing. So X train and Y train, and then X test. So from 75 to 100, so it is X test. Sorry, 75 to 99. It is X test. So X test means here you have in X test you will not be considering the dependent variable, that is response variable. Y test will be there for your will be considered as for the actual data with which you will be tallying to the predicted data. So you are having X train, X test, Y train, Y test, and obviously when you have segregated that data manually, so no need, if you have been segregating that data manually, no need of this calling from the sklearn model selection. You can manually select. Okay, then sklearn linear model, you can call the logistic regression. Okay, and for calculating matrices, that is the confusion matrix and all, you can call the matrix. For some For some more accuracy calculation, you can use C1, and obviously for visualizing visualizing your output, or even visualizing data also, you can use matplotlib. Okay. So in that case, what data we have already created, dummy data, we can call it as DFD, and that would be called with PD, means pandas dot data frame. Okay, you just pandas dot data frame means here you will be giving the variable name and the columns. Okay, so you can create this. The data is created. You can call different libraries, and then later you can if you want to see the data, you can see the head of the data. Okay, means in head five top value will be represented. Okay, and so on. If you want more numbers, you can mention the number also. Let's say you want to see first 8 data, you can see 0 to 7 the indexing data. Okay, if you want to see the data types of different variables, you can see the your our here this is our data frame, that is dummy data frame, so I have just given the name as DFD. Okay, so you can see the types of all the variables. Okay, so DFD dot types, so you can see over here that this UID is being considered as object type of data, gender is object, age is numerical, so it is in 64. Estimated salary is numerical in 64. Card purchased, it is also in 64. So why it is not reflecting as this one is, these two are the string data, so it should be string, but the string data is being considered as the object data in data dot frame. Okay, so data frame it is considered as object. Okay, so you can see the value count also, how many data are there for different variables. Okay, so dear gender, if you want to see how many gender values are there, how many, I mean in what way these are distributed, so you can see 6 females are there and 4 males are 6 female are there, 4 male are there. Okay, so you can call the real data also. So we have one real data, that is credit card data, that is for purchasing itself. So this is CSV in CSV format. So if you want to call a data in CSV format, okay. So here in Google Colab, you need to just upload the data. Okay, then you can use the data. It will not take from your it will not take from your local directory. Okay, from the local directory you can select the data, and again it will get uploaded. So the command is google.colab. I'm just going a little faster. Anywhere if you don't understand, let me know, because these are just quite basic Python programming. Everyone is quite, I expect everyone is quite acquainted with the Python programming. So these all things are not means difficult to understand. Okay. So from this local directory, you can get the data. Okay. Once the data is already uploaded, if you again upload it, so let's say here I've run this code, and I have this credit card data.csv uploaded, already uploaded on the Colab server. Okay. If you again run this, means let's say so it will again create a different copy for that. Okay, and it will see I have credit card data open, and so it is 100% uploaded over there. And see it is saving to credit card data to credit card data.csv. Okay, I think I had uploaded it long back. Okay, so that's why it is not it didn't put another copy for it. It has just overridden this data, the same data it has overridden. Sometimes it put the different copy. So if you can see this credit.csv is saved to credit card.csv data. So now you have to just call this data. So we can consider the variable as data set. So from the pandas, with the help of pandas, pd.read csv this data, credit card.csv. So credit card.csv, you can simply call it. So you can see the data over there, whether it is what uploaded or not. So you can see the size of the data also now. Let's say data set. Anyone can tell what is the command for size? Dot save now. So it is having 400 rows and 5 columns. So 5 columns as you can see over here, and this is having total 400 rows. Okay. So as here we can see, this is the this user type is object type, that is unique ID. So it is not going to contribute anyway, whether the person will be buying credit card or not. Okay. Next one is female. Male and female may contribute. Okay. So whenever you are going to consider this variable, okay, you are going to pass this variable for linear regression, so you need to convert these values. Okay, these are categorical values, so either you can convert it in 0 and 1 format or 1 and 2 format, any value you can give it over there. Okay. So here I'm just not converting this data, I'm just considering this variable is 0, 1 and 2. So I'm just considering these two variables as independent variable, and this one is a dependent variable for the classification. Okay. So I have considered the x variables as a dataset.ilog, all the rows, second and third column, and the values of that. So, and for y values, y variable, dataset.ilog. Okay. Uh, Fourth variable as a y variable. So this is called as means this data we have considered as for the classification. Okay. So now we can split the data into training and testing part. So with the sklearn model selection, you can import train test split. Okay, so that it will be doing what I told. It will be segregating data in x train, x test, y train, and y test. So this is the command, this is the function, that train test split. You can pass the variables x and y variables, and test site you are considering 25%. So training size will obviously be 75%, and random state, it is considering the data randomly. The random state 0. No, so I think randomly it will consider. I'm just little bit confused. Whether it will consider the data with the 0, it will be considering the data randomly, or it may consider data in a sequence. First 75% data, or any 75% data it may consider as for training, and less 25% data for testing. Okay, so as here we have given 25% already, so it will be considering a random basis. Okay, state random state equal to 0 means it will be considering the data on random basis. Okay, so 75% data for training and 25% data for testing. Okay, so now we can just what rescale the data, because you can see here these variables are just 19, 35, 26 and 27, but this variable is 19,000. So scaling is quite means quite different. So we can just put rescale data. Okay, we can rescale the data so that all the values will be there between 0 and 1, or you can put it into -1 and 1. Okay, and later you can apply the thing. Okay, so here you can just train text split happen. Now you can rescale the data. So just standard rescaler you can apply over there. Okay, so it will be rescaling for x train and rescaling for x test both also. Okay, because y train y test is nothing to be rescaled, because it is the categorical value 0 and 1 only. So for x train y train are there, you can just print first train values to see whether these two values are rescaled in what way. So you can see it over here, it is being rescaled from between 2. No, positive side maximum value is 2, and negative side maximum value will be -12. So -12, -1. So this range it has been rescaled. So this is a rescale data. So later you can apply the logistic regression. So this logistic regression, as we saw there, it is sklearn.linear model. So you can call the you can import linear regression, and you apply the linear regression, and in random values you are using, you are giving random values for linear regression, and that we are creating as a variable classifier. So classifier dot fit we can give, means either you can write linear regression dot fit, and you just give the values as x train, y train, comma, random state equal to 0, or you can create it in separate variable classifier, and then with the classifier dot fit you are giving the x train and y train values. Okay, so these are the, with this we can get our model fitted, and there are number of terms which are being reflected over here after implementation of logistic regression that I have just included over here. Okay, you can just read it. Then once our data is fitted, so we can go for the prediction. Okay, so with the classifier dot predict, classifier is nothing but a logistic regression. Okay, where logistic regression is taking input values as random values. Okay, so classifier dot fit dot predict, or you can write class logistic regression dot predict x test and random is equal to 0. So you can just predict the value. So y predicted value we have calculated. Now we will be calculating the confusion matrix. So confusion matrix will be giving us the value. See, with the sklearn matrix we are creating the confusion matrix, and the CM variable with the confusion matrix we are giving which value, which values we will be giving. One is the predicted value, that is what y predicted, means calculated value, this is the predicted value, and one was actual value. So actual value is nothing but y test. So based on these two values it will see the difference whether it is, or if it is the case for true positive or true negative, so it will be just collecting the counts. Okay, so 65 cases are there for true positive, and 25 cases are there for true negative, and the same way false positive and false negative 8 and 3. Okay, so you can see the classification report also with the sklearn matrix um, library only. So print classification report with these two variables, y test, y predict. So it will be giving all the values: precision, recall, F1 score, and support. Okay, and in that way for zeros it is 89% precision, and for one again 89%. For 0, 96% recall, 1, 75% recall, F1 score 92, and one phone score 81%. Support is 68 and 38. I think support I didn't explain. No, I precision recall support is like no specificity was sorry, uh, that one precision was all positive records. So I think support is for all negative records. It is there for little bit I'm not sure. You just see the text and you can just recall it from there. Okay, so you can see it over here. Accuracies for accuracy is 89%. Okay, so how can you calculate accuracy? Means you will be seeing how accurately you have uh, predicted. So all true positive and all true negative data will be there on the numerator and divided by all data: true positive, true negative, false positive, false negative. So total 100 total data means 400, and based with that formula you can calculate the accuracy. Okay, so you can here apply the performance measure also. This also calculate accuracy only for you. So you can call the sklearn matrix accuracy score to call the accuracy score by passing the two variable, actually two values. One is actual and predicted value. So you can get it over here as 90%, 89% accuracy. Okay, one more thing is called as ROC curve. So as time did not permit us to explain more about it, but here you can I can just tell you it is the graph between false positive rate and true positive rate. Okay, so false positive rate, we can calculate the false positive rate and we can calculate the true positive rate. And this one is the ideal, the red dotted line, you can see the ideal, and this one is the ROC curve. So the as much as for, okay, as much as far this is from this dotted line curve, that much accurate, that much accurately prediction, that much accurate performance is being considered. So around C, it is around 89% no accuracy. So it is around coming like this here, coming like this, no. So that is called as ROC curve. It is called as receiver operating characteristic curve. Okay. So it is basically another common tool for binary classification only. Okay. The dotted line represent the ROC curve for a purely random classifier, means it is for purely random classifier, and a good classifier stays as away from as possible. So that is as much away this is possible. So that is called as the good classifier. Okay. So that's that one. You can just visualize with the data, how much data is there for 0 and how much data we have calculated for 1. So the code is there. I think we are just exceeding with the time, so I'm just winding it up a little faster. Okay, so you can see the data as here with this in this section it is for 0 and this section for 1. So this is for the visualization. You can just see the code. Okay. And then so that is what the as an example for linear, sorry, logistic regression, you can just implement this different classification different classification techniques. Okay, those are let's say we had applied for I have implemented it for uh, training and testing data. I have implemented it for decision trees, okay, and k nearest neighbors, linear discriminant analysis, Gaussian naive Bayes, and support vector machine. These 4-5 techniques we implemented it over there. You can see accuracy with all the aspects. Okay, and you can, obviously the time is quite limited, so we cannot explain all those things. Okay, so here I would stop, and anything, just some comments I saw from here. Morning session feedback. Okay, that is feedback. Feedback. Sir, when precision and recall are same, what does it mean? So precision and recall, no, recall is there for all positive prediction. Okay, the percentage of all positive prediction. Okay, so that is called as recall, and precision is all positive prediction. But like no, in the recall, we are considering the which are actual positive, but we are predicting as negative. But in precision, we are considering all positive, which are actually positively predicted, and which are means falsely positively predicted also. So that is called precision and recall. Okay, actually, what happens? Where we can how we can use it to measure the accuracy? We can see we can like no we can see all these measures, and we will see which one is being robust means we can like no we can change the scenario. Let's say earlier we have considered 0 as positive or yes as positive, no as negative. Next time you just make it opposite, like fraud and non-fraud case. Initially you have considered fraud as positive, non-fraud as negative. So at that time your precision and recall thing will be different. And when you are considering fraud as non-positive, sorry, fraud as negative and non-fraud as positive, so at that time your precision and recall will be different. Okay, so by changing both perspective, you see which one is being more robust. Means which one, let's say first time you have calculated precision at 0.9, and next time if it is complete, it is coming as 0.05, then there is quite more deviation. These things happen when our data is quite biased. Okay, but when our data is like no symmetrically distributed and normally distributed, so at that time we find very little difference. Okay, any more confusion, anyone? So far I think what I have explained, everyone would have understood it. Just in just 2 minutes for question and answer round. uh, the question answer round is open. Anyone, any question what we discussed so far? Any question about that? Okay, if no question, we will stop over here. Deepa ma'am, shall we stop? Yeah, yeah, already it's 1:40 and they will get 20-minute
Yes.
time only for lunch.
Yes,
So from 2 o'clock, they will have next session. No, ma'am?
yes, sir. Yes, sir. Sure. Thank you,
Okay.
sir.
Yeah,
Thank you
thank
for your wonderful session. Yeah. Students, we have posted a feedback and quiz link in the chat box and Telegram group also. Please fill that. And we can resume back at 2:15. So 2:15, we can come back for the next session. Thank you all. So you can remain here. We are not ending the session. So you can just mute and have your lunch and you can come back. Thank you.
Thank you, ma'am. Thank you from my side also to everyone for listening me for so long time, and that also continuously. It was my pleasure also to give this session, and I also felt quite delighted. So thank you all.
Yeah, good afternoon all. Now, Neha ma'am, you're there?
Yes, good afternoon, ma'am.
Yeah, good afternoon. Yeah, now I request Mr. Syed to introduce speaker. Over to you, Syed.
Yes, ma'am. Thank you. Good afternoon, everyone. For this session 6, we have Professor Neha Gautam with us. Let me introduce Professor Neha Gautam. Professor Neha is an assistant professor of data science department in Jain School of Engineering and Technology. She is currently pursuing her PhD from Faculty of Computer Science and Information Technology at the University of Malaysia, Sarawak, and doing research on the topic of Drummy word recognition system. Her research interests are machine learning, deep learning, and computer vision. She has 4 ACI articles in these particular areas. This is all about Professor Neha Gautam. Ma'am, the session is over to you.
Thank you, Deepa ma'am and sir, for giving this opportunity. Thank you so much.
Ma'am, one more thing.
Yes, please.
Ma'am, would you like to take the questions in between the meeting or at the end of the session?
You are asking about the MCQs or?
No, ma'am. I mean doubts regarding the session.
In between, I'll ask parallelly that
Okay.
when a student will have any doubt, so we can.
Okay, ma'am. Okay, ma'am. Thank you. You can continue, ma'am.
Thank you. So, okay, I think so. Might be possible. Many students are familiar to me. Many students are not. So those are not familiar to me. I just want to discuss that we will have a session around 3 hours around. Okay. In this time, we are going to complete ANN a little bit complete. We will do some practical. After that, we are going to complete a little bit CNN, and we will do some practical. And then in between, we are going to discuss that how ANN will work. Means if we have one data set, means I'm just sharing the whole path of today's lecture. That if we have for any data set, So how we are going to process with the data set, and how in the last we will get a output, what will happen in between. And similarly with CNN, we will do that. If we have CNN model, first how to create CNN model, how data is going to be processed, how classification will do, all these things we are going to discuss in this way. Okay, and each topic will complete. So whenever you have doubt, ask to me, because you can understand a small topic we are going to connect. We are going to complete and connect to each other. So if you will not understand any topic, it might be possible the further thing you cannot understand. Okay, so whenever you have any doubt, just say that, ma'am, we have doubt, and then we will discuss in that time. Okay, so the path is ANN will complete first, then we'll do little bit implementations, couple of implementation. After the CNN will complete theory, and then we'll do implementation. Okay, so, and one more thing, please communicate to me, otherwise I'll be bored. Okay, so just like if you are getting it, not getting it, whatever you are feeling, if I'm asking any question, just respond. Okay, so for this session, please take a pen and paper as well as your laptop, because the mathematics we are going to solve and implementation also we are going to discuss. Okay, so let's start with ANN. If you have idea that what is means about machine learning, as you have completed, I think so, morning session, so you have little bit idea about machine learning. So there is a one more algorithm that is ANN, artificial neural network. So anybody can tell me what is artificial neural network, or any idea?
No, ma'am.
No. Okay. Any another student? What is artificial neural network? Okay. Any idea what is neurons in human body?
Yes, ma'am.
What is this?
I think they transmit impulses from one part of the body to another.
Okay. So, okay. Normally, I'll help you. That if anything is happening in your body, that will be connected in the brain to the brain, and how it's going to be connected with the help of neurons. Okay. So the simple thing, if you have a means, obviously you have two hands. If I pinch in your one hand, what will happen? The pinch, some cells behind your skin that will be activated. The signal will go in your mind. There is some neurons, and according some calculation will happen. Means, some signals will pass through the neurons, and the brain will say that that area feel pain. So it's just like pinch. So you can say, oh, it's pain. So the entire process is happening behind. So my question is, if I'll pinch in your one hand, an example, right hand I'm pinching at one place, and so will you be feel pain in second hand, means left hand? Okay, I'm repeating my question again. If I pinch in your right hand at a one place, so it might be possible that you will feel pain in your second left hand also.
No, ma'am.
Why?
The pinches happened only in one hand.
Because below the skin, the cell was not activated in your left hand. So directly, okay, all these things are related. We are going to connect with ANN. So just try to understand the psychology. Okay. So I can say that when I pinch in your one hand, the cell activated. So the one term is activated. That is necessary activation. As in your another hand, left hand cells is not activated. Na? So to pass the signal, activation is important. Okay. Neurons is important. That will pass the signals. So these two terms, I can understand that, okay, these two things is important, to pass the signal in human body. Similarly, ANN will work in similar way. ANN means artificial neural network. Okay, leave the network at this time. Just focus on artificial neural. Neural I'll replace with neurons, so it will be better. That artificial neurons. What does the means? The neurons is created by a man-made neurons, and according to this neuron, the system will find out that what is going to be happened, how something is going to be means you are going in the last, how you will find out what happened. An example, is there a pinch? So okay, you feel pain or not pain. So what will be your output? Something like that. This is going to be behind. Okay, now as I said, leave the architecture network. Now we are talking about the network. So in your network, you will have input. The same example as I took earlier, the input was pinch in your body. Okay, so similarly, some input will happen, and you will have output, and output will be like you feel pain. Okay, you feel pain, and something is happening between in your body. So same thing, it created by a machine. Means machine can follow same process, so machine can get a output, same process. Okay, so this is your input, that will be your output, and the between is like something is going on between, process is going on between from input to output. Okay, now okay, the bio is end here. Now we'll talk about the data science background. You have a data, but definitely this data will be your input. Okay, we are following supervised learning. In morning session, I hope you have a clear idea that what is supervised learning and what is unsupervised learning. So for ANN, we are following supervised learning. Okay, so data we are following as an input. Something is happening between. Just leave this word, that something. What is happening? Later we will discuss. Something is happening between, and you are getting output. Okay. Now the question will come that, okay, what will be my output? The output will be, this is a classification problem we are taking. Okay. ANN can also work, use for a regression. So that is a separate part, but in this example, we are taking as a classification. So ANN, you are working as a classification. So how many classes in the last? So number of classes according to number of this. An example, this is the example of binary class. Means 0 and 1, or yes or no, or whatever. Means binary, 2 class problem. This is the example of 2 class problem. Okay, now if I have a digit recognition, can you tell me how many classes can be there? Number of classes. Okay, fine. The digit is will have 10 classes, 0 to 9. Okay, so in this way you can define that how many outputs you can have. Means number of classes in your data set is equals to number of output. Now the question will come that what is input? So whatever you have in data set, that will be your input. Okay, now what is happening between? Between hidden layer is working. Okay, so now structure of machine learning will be in this way. Okay, this is your input. Input is not in your hand, as input is that you are taking some data set now. So input will belongs to your data set, so you cannot manipulate it. Output is also not in your hand, as classes is also predefined, so you can also not manipulate all these things? Yeah, definitely you can manipulate, but you have to manipulate the data set. So it's just like in the end of data set. After that, you cannot manipulate. Now between, what is happening? Now between, hidden layer will come. Hidden layer means that will help to convert your input into output. Some process is between is happening. Now, how many number of hidden layers should be there? Normally, you can go with 2. 1 is also fine. So an example, I'm going with 1 hidden layer. Okay, hidden layer is a developer's fault. Developer means you, me. We are developer at this time. We are developing one ANN model. So we have to define that how many hidden layers we want. Okay. So, and how many, okay, one more thing. In this layer, input layer has 3 neurons, 3 nodes, sorry. Okay. 3 node, 1, 2, 3. Output has 2 node. That is also one variable. That hidden layer is fine. Number of hidden layer is 2. That how many nodes for each hidden layer? That is also developer's fault. So an example, I said that 3 node I want for first hidden layer. And again 3 node for second hidden layer. So I have 1, 2, 3. 1, 2, 3. Okay, so my architecture has been means in my this architecture I have 4 layer, 1 input, 1 output, 2 hidden. Okay, so whenever I will write about the architecture, I can directly say that 4 layer, 1 input, 1 output, and 2 hidden. Now, how this hidden layer will connect? This hidden layer will be in this way. Each neuron, each node will connect with another node. Means each node of input will connect with the another node of, means according in this way, hidden layer, hidden 1, hidden 2, output in this. Okay. Okay, an example here is a node. Some node will have some value. So an example, the value is x1, x2, and x3. Now your question should come that how we can define that x1, x2, x3, all these things. So the answer is very simple. The value of input. Obviously, input will have some value, na? That will be your x1, x2, x3. Okay, this value you are going to calculate. How? In this ANN, 2 word will come, 2 parameter, weight and bias. Okay, what is the mean? Okay, at this time, just understand this word that weight and bias is automatic numbers. The algorithm is going to be updated. Okay, I'm not going on that much depth that how weight is going to be updated, how bias is going to be work, as we have only 3 hours. So just at this time, just understand that weight and bias will update automatically according to algorithm. Okay, so an example, the weight is W1, W2, W3, W4, W5, W6, W7, W8, and W9. Okay, so this is thing. Okay, I'm just going to remove this word. I'm saying only one node is we have. Actually, we are the system is architecture is going to be quite big, and we have to complete in time. Okay, so directly it's going to be connected with. Okay, so an example, this is my node. I'm just working on this node. How my the value of this node means what will be the value of this node? How we are going to calculate? So simple thing. This node is connected with W1. Okay, this node is connected with W1, W4, and W7. So W1 multiply by X1 means W1 is belong to X1, na? X1 plus W4 multiplied by X2 plus W7 multiplied by X3. Okay, means this variable will multiply by the weight and it is going to be connected with this node. That will be the output. Whatever will come, it will be the output, the node value of this. Okay, similarly, what will be the node value of that? Again, cross check. This node is created by this variable W2 is created by W5 if I'm not mistaken, and created by W8. So W2 multiplied by X2, sorry, X1. Be careful, that weight is connected with this node, and this node value is this one, X1, plus W5 multiplied by X2 plus W7, I think so, multiplied by X3. So whatever the value will come, that will be the value of this node. Okay, and similarly, you can calculate this node, and so on, this, that one. All these things you can calculate in this way. So this is going to be left to right, input to output. Okay. So until here, any doubt how weight is going to be, means how the node value, all these things are going to be calculated? Any doubt, ask to me, as we are going to jump in a second topic. Any doubt? Yes or no? No? Okay. Now I raise one point, that activation means signal I have passed, means from the input and output we have got. Now, what is the mean by activate? The activate means now the activate means I have passed this value will come. Okay, some value will come here. An example, y1, y2, y3. The value is how the value will be updated. I had just discussed. So an example, y1, y2, y3, three values is coming. Now we have to activate these values. Okay, we have to activate this value. How we can activate? You will have some activation function. Directly predefined activation function are there. You can directly use. Sigmoid is very good. Okay, Sigmoid is very good activation function, and it's a very good for output layer. Apart from that, if you'll just ask to me in a ANN level, I'll suggest to go with Sigmoid. But if you will go with a deep learning level, then I'll suggest you for hidden layer. The last layer, Sigmoid is best. Okay, always understand this point. I'm saying Sigmoid is best according to my understanding. Always keep this point in mind whenever you will have data set. How any algorithm or any parameter or whatever is going to be work, that will be different. An example, I'm taking ANN. It might be possible ANN is working with ANN is performing well with A type of data set, but it might be possible ANN is not performing well with B type of data set. Okay, so whenever I'm saying that Sigmoid is good, means majority level Sigmoid is good, but there is not a fix or freeze something. Otherwise, they will not give you any example to edit it, but they are giving to you. They means whenever you will develop a code, you have a chance to edit the functions. Whatever function do you want, activation function I'm talking. Okay, so whatever activation function you want, you can add it. means it's a developer's call that which type of activation function you want to use. But normally I'm saying that segment is a popular and good for last layer. Last layer means output layer. Okay. Now, what activation function we can use with hidden layer? Again, segment you can use. It's up to you. But normally ReLU, ReLU. Okay, I think so. E is small. ReLU. ReLU is good for this part. Okay. What is the difference in ReLU and segment? All these things in might be possible if in the last we will have enough time. So we will discuss that why I'm saying in a hidden layer ReLU is fine and why I'm saying in a last layer segment is fine, as we are in a fixed time. Okay. So at this time, this is my suggestion that okay, in between you can go with ReLU and in last go with segment. Only suggestion. Don't freeze this point. So this thing is going to be update this value. As I said, the activation is important. The same example in earlier, around 15 minutes ago, I said the activation is important. Without activation, the signals cannot pass. Whenever you will have any layer, that is a freeze thing. You have to activate it. Okay. So that we have discussed that how the value is going to be changed. Okay, yeah. Now it's good example in the PPT. You have this number. Okay, input. This is H1, H2. Sorry, not H. This is H1, H2, H3. Three weight. Just discuss now what is the mean by weight. So weight, I can say that with the help of these three weight. Okay, again I'm repeating. With the help of these with the help of these three weights, I'm going to calculate this value. With the help of these three weights, I'm going to calculate this value. This is the way of writing. And with the help of these three weights, I'm going to calculate this value. Apart from that, it might be possible the weight will be mentioned here. As I have mentioned in an example now, W1, W2, all values will be mentioned here. Both ways is right. It's up to you which way you want to prefer. I always prefer this way, as people will be understand very easily as compared to this. But for a documentation purpose, this is good. Okay, so as I said that this value is going to be used to calculate this value, hidden layer 1 nodes. Okay, so okay, what is my input? 0.5. That is a part of 1 plus second 0.9. That is a multiply by this weight plus third 0.3 multiply by 2.4. Okay, please do multiplication and tell me what is the value is coming. So this value now okay, yes. Actually, I forgot the weight bias. That is my mistake. Actually, that I forgot. When you are going to merge, so it will be like an example. This is W1, W2, W3, okay, W4, W5, W6, and so on. So your equation will be x1 multiplied by W1 plus x2 multiplied by W2 plus x3 multiplied by W3. Okay, this is your weight plus B bias. You can understand this thing in the pace of y is equals to mx plus c. When mx I'm going to represent with this equation and c is my bias, where bias will be, there is a no variable with bias. Bias always be constant. Okay, apart from that, I have mentioned clearly that weight and bias, which algorithm will define. Weight and bias algorithm will define. That is not in our hand. Okay, so whatever the algorithm will update, that is means in the background it's happening. Now you can ask to me this question that, okay, this is my input, that is x1, x2, x3. That is my input. Input is a fixed freeze for everyone, but weight and bias depend on the algorithm. So means if I'm following good algorithm, so there and okay, bias and weight both I'm talking at this time, that this is belongs to algorithm. So if I can say that if I'm following good algorithm, suitable algorithm, means my performance can increase. So in this way, you can understand how performance can increase by ANN just because of the weight and bias and the algorithm which updating my weight and bias. This is the important, okay? The algorithm which updating my weight and bias, because the main focus is this, that will help me to get the good performance. Okay, apart from that, hidden layer, that is also a good point, that how many hidden layer we are going to use. Normally 2 hidden layer are good normally, again developers call. Third point, number of node. As an example, there is a 3 node. How many nodes we are going to use? As you can see, each node is going to connect each node of previous layer. Means each node is important, and each node is going to be connect with the output layer. As there is a output nodes, there is a 2 node of output. So each node of hidden layer is going to be connect. So number of node, weight and bias, how it's going to be update, and number of hidden layer, 3 good parameter. Okay, those students who have idea about the ANN, at this time I'm not talking about the learning rate, so please leave learning rate behind. At this time, just follow with me that these 3 nodes is important. Well, sorry, these 3 parameters are important. Okay, now the question should come that, okay, number of node, developers call. Number of hidden layer, developers call. So, but weight and bias is not a developer's call. Okay, means a developer cannot control all these things. So we can control the algorithm who is going to update it. Means directly, not we can control, but indirectly as a developer, we can control it. So which algorithm we can use to update weight and bias? The question should come in your mind. And if it's not coming, so dear, you are not getting my point. Okay, this type of questions definitely arise. So which algorithm we are going to use to update the weight? Now, back propagation algorithm. Back propagation algorithm. Okay, I'm just explaining this algorithm with a small example. Okay, just one example. Okay, so a question for you. Number of node means how many number of node in input layer, hidden layer, okay, and output layer. This is first question. Second question. Number of node, how many hidden layer? Third question. How many classes we are going to define? Means the output has how many classes, okay? How many classes that? How many classes we have as output? So please give an answer of these three questions. And if you cannot give, so I'm sorry, but there is a basic means you should improve. And any doubt with any doubt or any topic you want to discuss again, just feel free. As in the between, you please cross check whether you are learning right or not. So these three questions, give the answer, and then okay. And at this time I'm going to start back propagation. Okay, so I'm going to remove this question. I hope you will give answer. Okay, so this is my equation. This is my model, a CNN model. Sorry, ANN model. Okay. So normally I can say that y1 is equal to x1 multiplied by w1, because y1 is created, y1 is created with the help of that one, this one, and this one. Okay, so the equation will be x1 multiplied by w1 plus x2 multiplied by w4 plus x2 multiplied by w7 plus b. Okay, might be possible many time if you will do Google, might be possible many time they will not use b here, or might be possible they will use b here. Normally because just simple, y is equal to mx plus c. Most of the time you can imagine that c is equal to 0, so that time this equation will work. If they will say that no b the c is not means b bias is not a 0, then the entire equation will work. Okay, so the only the writing way, but the real equation is this. Okay, so if I say that what is the equation of c1, so c1 will be c1 is creating with the help of that one, this one, and that one. Okay, so w10 y1 plus y2 w12 plus y3 w14. This equation is going to be followed for c1, and similarly you can create an equation for c2. Okay, now an example, one sample. Okay, one sample we are giving as an input, so these three nodes will be activated, these three node will be activated, some calculation will come, some activation function is going behind. Okay, that node will activated. Okay, in the last this output layer, and then you will get output. Okay, I hope in morning session you have got an idea that what is data set, training data set, and target data set. Okay, if you do not have idea target data set, please ask to me, because at this time we are going to use target dataset. Okay, so directly you can say that this is a binary problem. So an example, the output, the prediction which my model predicted. Okay, the prediction is 1, and I'll have a one target data set also where I'm going to compare. This is my target data set. So an example, according to my target data set, it should be 0. Just hypothetically, I'm saying, just imagine that what my ANN is predicting and my target was defined, that is different. An example, my prediction was 1 and my target was 0. Now, wrong prediction. Directly, na? Wrong prediction means my algorithm has some problem. Now, what to do? I have defined you earlier that input output you cannot control. Developer has defined the nodes, hidden layer, everything. Now what? Wait. Okay. Wait. That can be updated in between. Otherwise, each time you have to create a model, it will be quite irritating. Means 2 layer, 3 layer, number of neurons. All the day you will do the same thing. Not possible now. So now the easily thing you can update wait. Wait means don't go with the pronunciation if any issue. Wait, I'm talking about this thing. Okay. Now what will happen? Now the algorithm will come, which I was saying earlier, backpropagation algorithm. Okay. I'm explaining you that what is the all these things and why we need it. Both things is important. Okay. So now the backpropagation will come in the frame. Backpropagation will say that wrong prediction. So loss. What is the loss? Loss means prediction minus target square. Okay, there is a various type of loss functions are available, but I'm talking about the backpropagation loss function. So don't confuse with this thing, because in a regression you can see a lot of type of loss function. So those type of loss function I'm not saying it here. I'm just saying the basic loss function which backpropagation is by default it's using. This is the loss function. So loss was 1 minus 0, 1 loss. Okay. So loss according to loss, this weight, okay, not exactly this weight. This weight, that one, and this one, all 3 weight will update. Okay. Now, how these weights are going to be updated? This question should arise that, okay, I understand that this weight we have to update, but how? Okay, so the equation for this. Weight new is equal to weight old. Old weight means at this time this weight minus learning rate. Okay, now learning rate come in frame. And this is very important. Now learning rate and differentiation of the individual weight. Sorry, a differentiation of loss in respect to this weight. Okay, this is my equation. How there is going to be calculated? Just put in a aside, leave it at this time. This is important, learning rate. Okay, so with the help of this equation, each weight is going to be update, and my algorithm will work in this way until my input node will not update again. Means obviously now that will be updated. So with the help of this will be updated, then this will be updated, and then all nodes, value, weight, all these things is going to be updated. Okay, now when input layer will update, again the system will follow the previous, which I discussed earlier, this to this direction. Okay, again we'll check loss, whether you have loss on right prediction or wrong prediction. If wrong prediction, again you will go here, again you will go here. This just prediction will not be right. That entire thing is called backpropagation. Okay, and then how many times you are going left to right, right to left, left to right, left to right, that is called epoch. And the epoch can be defined by developer. Means how many times you want to go. You can create means you can go with a high value of epoch, you can go with average value of epoch, but don't go low value of epoch. Okay, and definitely epoch will take your laptop, means consume your laptop memory, all these things. So if you do not have good configuration, please put a epoch less, 10, 5, 10, 8 is quite enough. Okay, so all these things is epoch. This word you are going to listen again, is that's the reason I'm point out all the point here. Okay, now learning rate. What is the learning rate? Learning rate, simply you can understand that the speed that my system will follow to learn. Learning means the prediction. Okay, simple, I can explain you that a faculty is teaching to the student. If the learning rate means the speed of faculty teaching, if it's quite high, so student cannot be understand. If it's quite low, the syllabus cannot complete on time. Similarly with learning rate, don't put learning rate too high, okay, and don't put learning rate too low. Normally 0.001, that's a good learning rate, but my favorite 0.01. Okay, again I'm saying that it will always be dependent, because all these are parameter. There is a no fixed thing that you have to follow, depend on the data set. Range, I can tell you that what is the range of learning rate, 0 to 1. Okay, don't go with 0. Okay, why I'm saying, because this value will be 0, so this multiplication will be 0, so always your old value and new value will be similar. If my weight is not updating, means nothing is happening, and if nothing is happening, how many time epoch you can do? You will not get. Each time you will predict wrong, means some value should be here. So I don't go with 0. Okay, so this is the entire thing, that how my back propagation will work. So here I think so discussion regarding ANN should be completed. I'm just checking my okay, one topic is also left. Okay, one topic is also left, SGD, gradient depth. Okay, so gradient, I hope you know that, and if you do not know, so just understand in this way. It gradient in a 3 part: SGD, some is first gradient descent, GD gradient descent, and mini batch gradient descent. Okay, sorry, mini batch. Okay, in this SGD has one problem. In SGD, one image will come. This is your input layer, this is your hidden layer, and this is your output layer. Okay, one image will go. If wrong prediction, back propagation will work, will go here, then will go until the prediction will not right. Okay, and what is happening in between, the weight is going to be updated. So I can say that for one image, my weight is going to be updated. My means obviously all weight many times is going to be updated just because of one image. The SGD has this issue, so processing time is quite slow. So mini batch gradient descent or gradient descent will come. Both has something, that a bunch of a image. An example, I say that okay, 15 image is equals to one batch. Okay, so a batch of image will go one time. So if I have an example, I have 60 images. So with the help of SGD, my 60 times this process will go, weight will update, this again process will go, weight again update, all these things 60 times. And if I created 4 image batch, means 4 batch will I have, obviously the simple mathematics, na? 15 sample in one batch, so 4 batches is equal to 60 samples. So 4 times the process will go, 4 times. So to save the timing, the gradient descent come in a frame. So mini batch is a good, and gradient descent is also good. Now the question should come in your mind that, okay, ma'am, why prediction minus y target square was the loss function? That is understandable for one image. That one image prediction is one, or one means any one value, and target is also one value. But for 15 batch, there is not a one. Now what we have to do is how we are going to calculate the loss function. Again, I'm saying, if this type of questions is not coming in your mind, please think critically. Please try to connect all these points. Okay, and if you're thinking that this is not important, so dear, always understand the data set you can take, coding it's all available online, you can apply. There is not a learning. Learning is logic. Because first time it's happening that nobody is talking to me. Means it's like a surprising. I thought that there will be a two-way communication. Okay, so never mind. There is a your means it might be totally fine that you are learning in this way. That is totally fine for me. But this type of questions should come in your mind. Okay, so this is your equation for one sample. But if you have 15 images is one time, what is you are going to do? So nothing, only summation will come in your frame. Okay, y prediction and y target square. Okay, only summation means the loss of calculate the loss of each sample and then do summation. It will be your entire loss, and according to this loss, the weight will update. Okay, so this is the way how the gradient descent come in a frame and how it solve the problem which SGD, Scottish gradient descent, created. Okay, so here ANN completed. Any doubt, anything, feel free. Okay, yeah, any doubt, anything, please feel free. Otherwise, we are going to discuss. Sorry, I'm so sorry. Yeah, otherwise, we are going to discuss implementation. So, any doubt? What are the output classes? But the output classes is like okay. An example, you are working on any data set. So, how many output do you want? The basic example, if I have a data set of digit recognition, the basic example, digit recognition. So how many outputs I can have? Okay, so number of output classes means if I'm working on digit recognition. Okay, so an example, I have 100 samples. So these 100 samples, I want to divide it into some categories, some classes, or some groups. Okay, I'm talking about the classifier at this time, but at this time I'm saying groups. Groups belongs to clustering. Okay, so don't be confused. So digit, how many groups classes can I have? I have 10 classes. 0. This class belongs to 1. This class belongs to 2, because this 100 samples can be 0 class, can be 1 class, can be 2 class, can be 3 class, all these things. So this is my output class. Clear? An example, I'm trying to find out the gender of a human. So normally, not in that means not in hypothetically I'm saying anything, but normally I'm saying the male and female, 2 class I can have. Means either the group of male or group of female. Again, I'm saying when I'm saying about the groups, that means I'm giving the example of clustering. Clustering can also use for the classification. There is a little bit tricky thing, but clustering can also use for the classification. So those are similar. Okay, so bit clear this one? Yes. So digit neural network model will have 10 nodes. Yes, perfect answer. And that's the reason when I said this thing, I mentioned that the output has 2. So I clearly mentioned that this is the binary problem. Binary problem is I have only 2 classes, 0 or 1. So this clear or any doubt? Bacha, any doubt? Anyone? Or shall we proceed for implementation? At least say yes or no, so I can move.
Madam,
Yes, please.
I read somewhere that if there's two output nodes, that it can produce more than two classes, like 0, 0, 0, 1, 1, 1, I don't know, something like that, 1, 0.
No, I didn't get your point question. Can you explore more?
You say that two output nodes, it can be a binary class, so it has two classes, isn't it?
Okay. Yes. Binary.
So
Bond.
yeah, so it is a 0 or 1, isn't it?
Yes, 0 or 1. Yes,
Yeah.
fine.
So I read somewhere, but it can produce more than two classes, which can be maybe 0, 0.
No.
Yeah.
Okay. An example. You can create 2. You can create 3. You can create 4. That is fine. You can increase the number. That is totally fine. Clear, beta?
Yes, ma'am.
Yeah. Okay. So in this way you can create. Okay. Now the question should come. Just a minute. I think so. I have a data set. Okay. I have this data set. At this time you can see I did some cases. I'm okay. Sorry, I'm not from bio department. Means I'm not that much familiar with biology, so I do not know what is the mean by these classes. This is just a data set I'm saying. Okay, this is one class. That is second class. Okay, and that is third class. And there is a no further class. So I have only output can be only belongs to these three classes. So it's totally up to us. Normally I can say that will I'll mention that one. Okay, and the second will I mention 2, and the third one I'll mention 3. That is I can do, or 0, 1, 2, or 0, 2, 4. Up to you, beta. There is a no. Only you should understand that 0 means what. So 0 means this class. If I say that this is 2, so what is the mean by 2? So you should understand, because in the last you have to connect it, na, that what is the output. So in the last you should understand that, oh, 2 means this class. So whatever number you want to give, you can give. Only in a different way, you should recall that 0 means this class and 1 means this class. Okay, so I'm going with one implementation at this time. ANN, that is my data set. Let's talk about the data set a little bit later. Let's start. Okay, NumPy to Python. I hope you took a lecture of Python, so I hope you can understand Python at this time, because I'm not going to be depth in the Python area. I'm just going with machine learning things. Okay, so NumPy I'm using to read. PD I'm using to read my file. NumPy later I'll define that where we have used NumPy, and TF for TensorFlow. Okay, NumPy as a NP. These three package I have used. So let's run. Okay, TF version is not that. Okay, now I'm calling my data set. This is my data set. That is data set in .csv format. Okay, one example we are going to take .csv format. One example we are going to take in an image format with ANN. So both example you can understand. So .csv I have read. Okay, so so this is my data set. Okay, so now understand this is my unique value. So for machine learning, we can remove the unique value. We do not need it. Okay, so This value, this column we can drop. The customer ID also unique value we can drop. Surname is also not that kind of a unique, so we can drop. Okay, rest are important. Okay, which column you want to take, which column you want to remove. Normally unique value you can directly remove, not a big issue about it. Apart from that, there is a feature selection approach, which is not a part of today's lecture, but out of this thing you can have a look. That feature selection algorithm you can use to find out which feature is important. Now the question should come in your mind that, ma'am, what is the features? Beta, features means columns. In machine learning, we use features for the column. Okay, so there is should be no confusion that which column or which variable, are normally mathematics term, which variable is important or which feature is important. The feature selection algorithms you can use to find out this point. Okay, normally as a developers, I can suggest you that remove those columns who has unique value. Unique value means this thing, number 1, 2, 3, 4 means each rows has one unique value. Okay, so means that is not useful for us, so we can remove it. Okay, so data set I'm taking as X, and all value, these values means just left these values. Okay, and Y just go with this value, means last one. Okay, so let's run. My data set is this: France, female, and so all numbers. Okay, and Y will be my target data set. What is the mean by training data set? What is the mean by target data set? I hope I'm imagining this point that you know these things. If you have any issue regarding this, please ask me, as you have completed the basic things, so I'm just assuming it, and you have completed the Python also, so I'm assuming that you are quite familiar with this thing, that how to remove columns. So I'm not going to be explaining that how we are going to remove each column, all these things. I'm just imagining that you know all these things. Okay, now at the one situation will come in mind. Okay, this is not useful for us, so we have hide and imagine this is my data set, and that is my target data set. Okay, this is categorical data, means characters are here, and normally only one data boost algorithm is this who can handle categorical data, means who can work with categorical data. Apart from that, till now what I have seen, that machine learning algorithm cannot work with categorical value, means these two features is important for me, but that is not a useful at this time, as this is the characters, so I have to convert into numbers. This is a real problem, and this type of problems definitely can occur when you are working in realistic data set. And that's the reason might be possible many times you heard this word, that the theory which you are learning in a class and when you will do practical in a realistic data set, there is a two different thing. Okay, because when we discuss the ANN, that time I didn't say this point that this type of problems can come, but when we are doing practical, now you have seen that this type of problems can occur. Okay, so these two features is important, but we cannot use directly. So what we have to do, we can convert it into numbers. Now the question will come that how? Okay, if those things will be your target data set. So as I have said earlier, 0, 1, 2, whatever, you can do manually also, but this is not the target. Now what to do? Now there is a lot of algorithms you can follow. Just to Google that how to convert categorical data into number. You can find out 3, 4, 5 type of algorithms. There is a good algorithms. I'm not going in this much area, so I'm just saying label encoder I'm using, means encoder. Okay, so this is the package I have import, label encoder. Label encoder I have store in LE, any variable, and after this variable I'm going to apply only first 2 rows. Sorry, not first 2 rows, only second rows. Sorry, my mistake. Okay, so when I run apply it, I have applied. Let's run. This is where I was. This run I have done. Okay, here I was. So when I run it, you can see that my France, this thing is not completed. Okay, the France is not removed. The female male has been removed. If I'm not mistaken, this is for means 0 1. Na? So one female means might be possible 0 for female, 1 for male, or might be possible 0 for male, 1 for female. When we will see this thing, easily we can find out. Means we have to just compare. Now, how to handle the France thing? Again, I have used another algorithm just for the understanding that two algorithm you can see. Okay, means two type of algorithm. I have the name at least I'm going to share you today. First is label encoder, and second is column transformer. Okay, sorry, not column transformer, but one hot encoder. Okay, so one hot encoder. Now I have only this problem. This column I have a problem. This is the column is this one, geography. Okay, so only for this column I'm going to apply my one hot encoder. So when I applied it, okay, my all value has been completed and is converted into numbers. This is the important thing which always you have to follow if you have categorical data. Always, until you are not using cat boost algorithm. Okay, cat boost algorithm. Cat boost is a different another one type of algorithm. Again, I'm saying who can work on a categorical data. So apart from that, means this can work on categorical data. Apart from that, mostly algorithm which I have seen till now cannot work with categorical data. So you need to convert it into numbers. Okay. And when I'm saying that, I have seen as men daily, there is a lot of research is happening. So might be possible some algorithm come who is good with the categorical data. So might be possible. So I'm saying that I cannot say that is not happen because in 2017 CataBoost came. So before that nobody can work on a categorical data, but CataBoost came now. Who can work with categorical data? So something that type of research is happening. Might be possible. So I just put it this point. Okay. Now I have data set. Data set I have converted as per my requirement. Now I need to do split into training, testing. Okay. When I'm doing training, parallelly I'm doing for targeting also. So I need 4 groups at this time. Okay. Data set I need into 2 groups, training and testing. A training data set will be in 2 parts. One for training and this is for target of trend. Any word you get training. Okay. That is also for testing data set or target data set for testing. Okay, these 4 things I need. That is optional, and how it's optional later I'll discuss. Okay, this is optional, but without this you cannot predict you cannot evaluate the performance. So if you do not want to evaluate the performance of your model, then you can leave this thing. Rest 3 is compulsory. But if you want to predict, you want to calculate the performance of your model, then this is important. Okay, so let's start. I have divided. This is my data set. That is my this is my target. This is my normal data set. Test size 0.20 means 20% I'm taking for testing. Rest 80% I'm taking for training. Okay, yeah, and then random state. Normally you can go with 0 and 42 also. Okay, now feature selection. The feature selection is important as the brief idea I'm just giving to you. As you have 42, 41 some range here, you have 1, 2 means quite a small range, and you have salary in 5 digit and balance in also 5 digit, means the range of a data set is very low. So 0, 1 also you have, and in lakh you also have. So quite a big data range you are taking in this data set, and that is not too good. Okay, so you have to convert all data set into one range. One range means some specific range. Okay, means these things you have to minimize, or these things you have to increase. Okay, so that is called data normalization. So data normalization. Okay, at this time I'm not going in that much depth. So it's just like feature selection we are using. Sorry, feature scaling we are using means to convert your all data set into one feature, means some around values. Okay, so when you did this point, when you convert it into X trend, Y X text, Y trend, Y text. Okay, so just understand this is your target data set and this is your training and testing data set. Okay, so that is my target data set. So target data set 0, 1, fine. This has an issue, 0, 1, some lack value. So you have to apply feature scaling on this data set, means my normal data set. So I'm applying features scaling on X trend and X text. Okay, no need to apply on target data set. And normally at this time, never you have to apply on target data. So don't worry, each time you will apply if you are doing feature selection, and I have explained that why we need it. So whenever you will do, you have to apply here. Okay, now we are building our, so now we are building our ANN. Okay, okay, fine. So ANN. So normally this is the command to write TF TensorFlow I'm using with Keras, sorry, model sequential. Okay, and the name is ANN. Okay, now in the under this thing we are going to explain that what is my model. Okay, now dense layer means number of layers, means hidden layer I'm talking at this time, because one is data set na. Okay, data set has how many features? Please count how many features will have means to our data set. 10 features, no? Yes, 10 features. So means 10 nodes we will have as an input. That okay, means in our input layer will have 10 nodes. 1, 2, 3, 4, and so on. 10. Okay, 10. Okay, how many nodes we will have? This is hierarchy data set. How many nodes we will have in a output layer? Yes, right. 2, 0, and 1. As you can see here. Okay, now in between, what will happen? That developers call means we are developer. We are building a model, na? So we are developer. So what will be the number of hidden layer? How many we want, or what the activation function? All these things. Now let's see. Okay, and that's the reason when I said na, the input layer nodes and output layer nodes we cannot control, but this thing we can control. So I said that okay, one layer. This is one hidden layer. Nodes, how many nodes? 6. Okay, activation function value. Okay, fine. Means one hidden layer I have created. And how many nodes? 6. Okay, now second hidden layer. Okay, same number of unit, 6, and this thing. Okay, this is optional. Means not that much optional. Definitely, you have to do that. But this is, it's up to you. As I said that we have binary 0 or 1. So I'm just saying that the output will be only 1. The output will be say either 0 or 1. Means anything it can say. Okay, you can go with 2 also. That is in your hand. There is no issue with behind it. For binary, I have write down 1. For when we will do second thing, na, that you can understand better. Okay, so now this is output layer, na. So I have said that output for you can go with segment. For output, segment is really good. You can follow. Okay, now I have assigned. Okay, now you can understand that under ANN, I have assigned that okay, these 2 hidden layer we are working, and this is one output layer. Now you have to compile. Don't forget. Please make sure this word activation is important. After that, compile is also important. Okay, whenever you will use compile, That time optimizer, one word will come in the mind, that optimizer, which type of optimizer you want to use. The Adam is famous and I really like it. Adam optimizer. What is the function of, what is the importance of optimizer? The optimizer will work to minimize the loss. You can recall with the figure which we explained now. That time I said that loss is if means prediction minus target square is loss. So the system will focus to minimize the loss. Okay, so this is the entire thing. Okay, now how to calculate loss? At that time I clearly said that the loss function is y predict minus y target square. Okay, and that time I said that this is by default. As a developer, you can use your own loss function, as I have used MSE, mean square error. There is also loss function. So any loss function you can use according to this. If you're not using, the system will take a by default this function. Okay, and this according to this, the means now you can understand everyone. At this time we talk about the back propagation, we talk about the optimizer. Everyone is just focusing that minimize the loss, because the loss will be minimized, so there is a high chance that performance will be increased. Actually, in few cases it happened that loss is minimized and accuracy is also not good, but most of the time hypothetically you can understand, means just normally you can understand this point, that okay, normal cases, if my loss will be minimized, my performance will be increased in normal cases. Okay, whenever you will go in too much depth, that time you can understand this point, that this is not a right equation. So again, at the same time I'm saying this is not a right equation, but normally you can understand this point, that if my loss is minimized, my performance will be increased. Okay, so that's the reason everyone is focusing only to minimize the loss. Okay, I didn't run after this. Okay, now okay, I have created my model. The model name is ANN. Here model number is ANN. Okay, now fit function for training. So ANN dot fit function. I hope you have done any implementation in a morning session, so you can understand that fit function, all this, how we are going to write down. Okay, X trend and Y trend. This is my target for that training data set, and this is my training data set. Okay, at this time we are not using target data set, we are just doing training. Okay, batch size, I have explained you that what is the mean by batch size and epoch. Okay, always understand this point. How much your epoch is going to be increased, the performance also be little bit increase, and loss will be little bit decrease. If it's not happening, that means either the system is not activated, as I've said now. Your equation was weight new is equals to weight old minus learning rate and loss in different sum, anything. Okay, so either if your loss is not decreasing, okay, that means this is 0, or this is 0, means there is a two condition: either your system is in saturation point, or means obviously when this will be happen, this value will be equal, means system is not updating now, means that your directly or indirectly your system is in inactivate condition. Okay, so normally we will not follow this condition. Normally we will say that might be possible the saturation will come. Okay, but both thing can happen. Okay, so let's see, epoch is 100. Let's run the code. Okay, you can see here this one loss, then loss decrease, then more decrease, loss is going to be decrease. Okay, and accuracy is going to be increase. This is testing accuracy, because we are just giving testing data set. Okay, so go down. Yeah, 100 samples run. This is loss has been decreasing now, so loss is this quite low. Okay, you can say, ma'am, this is loss and then it increase. Definitely means the weight is updated wrongly. Okay, so that is also happening, but continuously not increase. If continuously is happening, means after that is again decrease, so it's fine. Little bit up and down is fine. Okay, accuracy is this, that is training accuracy. Now we have trained our system. Now what to do? We have to test. So let's test the system. Okay. So for testing, X test we need. Okay. Again, I'm saying X test we need for the testing. Means testing data set we need. Testing means target data set of testing we need to evaluate the performance. There is a two different things. Okay. So don't be confused. So for prediction or evaluation, means NN is a model name. Dot prediction or evaluate, both things you can use. The evaluate I have used in another document. So we are going to see there. Okay. Now this is testing. So we have applied. Okay, why predict should be greater? Because as I said, ANN can use for regression also. So for regression, you're not having output in 0 or 1. You are going to have an output. Okay, just a minute. I'll explain you. Means I can show you. Okay, so I have run this command. Now let's see what is by prediction I'm having. Okay, you can see there is a no 0, 1. There is some value is coming. As I have mentioned that ANN can also work with regression. So what to do? We have to find out some threshold value, and with the less of threshold value will be 0, and greater than the threshold value will be 1. Any equation. So I have created that. Okay, if by prediction is 0.5, more than 0.5, so it will be 1, and then it will be 0. Okay, so let's run. Now you have created 0 and 1 converted. Okay, so in this way you can do that, and this is a realistic problem which you can see many times. And after that, this is my confusion matrix. I hope in morning you have idea that what is the mean by confusion matrix, and this is my accuracy. Any doubt regarding this practical? If you have, please ask to me. Okay. After this, I'm going with another example. This is the image data set. Any doubt? Yes or no? Yes or no? Because we are in a rush. We have to complete a lot of things today. No doubt. Well and good. Okay. Okay. Now I want to tell you a important point, and please try to understand this point because this is quite important and might be possible. You will not find out easily on Google this point. Okay, because that is understanding level. Okay, normal whenever you have data set, this data set means one sample. Just this data set means one sample. So what I can say that I have arranged my all samples in row wise. Okay, I can say this thing, and this is my target data set for this sample. Means my samples value means my value which is important for one sample. I'm going to arrange in 1D, one dimension. This is my second sample. That is my third sample, fourth sample, fifth sample, and so on. Means I have to arrange my all samples in row wise. Means in 1D. This is important point. Again, I'm highlighting this point. This is quite important. That your samples always be in one dimension. After that, you can do classification. Okay, because now coming all experiment, we are using this logic. Okay, now if you are taking with image, I hope you are familiar with image. That image is normally with 2G. Normally, don't confuse. I'm saying normally. Otherwise, you can say no, my image can be 3D also. Definitely can be 3D, but we are just saying normal cases 2D. Okay, so or 3D, 4D, whatever. But image is not in a 1D. So normal case, you have 2D image. Now you have to apply ANN. How you can do? Definitely you have to convert your 2D to 1D. Only this reason you have. After that you can do. Otherwise there is no way. Okay. So this is the important that 2D to 1D you need to convert. Now how you can do? Okay. After that, another topic will come in a frame, that feature extraction. Okay. If you can do Google, a lot of type of feature extraction algorithms are available for images. Okay. Earlier I used feature selection. That is a different thing. Those are going to say that which feature is important. Means feature extraction already done. After that means some features you have. After that you will find out that which feature is important, which is not important. That is feature selection. But feature extraction we will do to find out the features. Okay. And the features is, again I'm saying, these are the features. Means the value, this is the features value. Okay. Feature extraction is not in our syllabus, so we are not going. I'm not going to do discuss a lot of things in this way. Only I'm point out these chapters which you can do. Means you can have a look by yourself. Means how all these are going to be connected. This is important. Okay. So I have my data set. The size of data set is 28 cross 28. Okay. Obviously, I hope you can understand this point that image is in a matrix form. 2D image is in a matrix form. And 60,000 is a training sample, as there is a mention. Okay. So this is a MNIST dataset, standard dataset. MNIST English digit dataset. So English digit means 10 classes. Okay. So I'm not going to run as it's going to be take a lot of time. So let's start and then I'll explain you what is the output. Okay. So I have loaded this data set and divided. Okay, the data set is already divided. So these 4 classes I have called from this data set. Xtrain, Ytrain, Xtest, Ytest. I hope you can understand that Xtrain is training data set. Ytrain is target data set for training. Xtest is your testing data set, and Ytest is your target data set for testing. So very easily we have divided. Okay, this is a standard data set. It's quite easily available. So I have print all the value. The printing is here. Okay, now you can ask to me that, ma'am, this is 3D because 3 value we have. So yes, you can say this is 3D. You can say. I'm not saying you are right. I'm saying you can say. Okay, that is the means number of samples. And this is the size of each picture, each image. As you can see here, this is the number of samples for training. And this is the number of samples for testing. So as you can see here. Okay. And apart from that, always remember one point. Number of samples for training, it should be equal to number of samples for target data set of training. Should be. If it's not equal, you are doing wrong. So in this way, you can cross-check. You can cross-check. 6611. Okay. So division has been completed. Okay. Now I have run the first sample of Xtrain. This is my sample. Means first image. Now you can see, ma'am, this does not look like image. Definitely, it's not look like image as I have print it in a matrix form. Why? I'm going to explain now. Okay. 0, 159, 252, 253. Okay. Not 255. Not more than 255. So I can say that my minimum value is 0. Sorry, my minimum value is 0 and maximum is 255. Okay, means this is the range. This is pixels value, beta. So don't be confused that how this value comes. This is the pixels value. Obviously, the image is a combination of pixels. Each and pixels are represented in a color. So each color has some unique value. Okay, so each pixel has some unique value. So this is the pixel value. So I can say that this is the gray image because gray image has this range 0 to 255. 0 and 1. This is the black and white. Okay, so I can say that this is the my gray image. Only for this perspective, I print it. Okay. Now, I have 2D image, 28 cross 28. I have to convert into 1D. How can I do? I can use feature extraction, definitely, but I'm not going to in that much area. So I'm just saying that 28 cross 28 means an example. If you have 1 1 1 0 1 0 0 0 1, this is your image, an example. So you can convert into 1D in this way, that one, either you can follow horizontal or you can follow vertical. It's up to you. I'm following horizontal. So 1 1 1, then 0 1 0, then 0 0 1. Okay. So in this way, easily I can connect. So you can ask to me that, ma'am, why we are, means if we can convert it into this way, so why we need feature extraction? Because feature extraction will help you to increase the performance. Okay. In this way, the performance will not be good. You can see in what the performance will be quite poor. Okay. But I'm just doing in this way. So you can understand that 1D is important before classification. Okay. So in this way, I have converted with the help of this reshape. That is number of sample, and in this time you are going to convert it into. Okay. How this number came? Just multiply 28 plus 28. This number will come. Okay. So in this way, I'm going to convert. Okay. And that is for means normalization, as means you will have, okay, maximum you had 20 to 25 number now. So each number will be 0 to 1. Means all pixels value you will going to divide it into 0 to 1, and you will have some decimal value which means 0 to 1. So this is just a optional thing, but it will help you. Means not that much option. Many times it helps to increase the performance because of the normalization. Earlier we have discussed that the values quite big up. So someone is saying something, as I'm not able to listen. Vishnu, yeah, Vishnu, you are saying something. Vishnu. Okay, fine. Okay, so this is the run I have run. Okay, sorry, actually I didn't run earlier, so I'm having this error. Wait, now I should run from over. Okay, now again, that same thing I have done earlier. Actually, same code I have put. So I have one. Again, one is also fine. Okay, there is no issue with the one output. One output means you will have either 1 0 means 0 1 2 3 4 5 6 7, whatever output you can have. This is also right. Okay, so there is no issue. Actually, I just copy paste from behind, so this is happening. Okay, now compiler. Sorry, Adam. Okay, so in this way, I'm using compiler, and inside the compiler, I'm using optimizer Adam. And this is actually in earlier I have explained you each step in a proper way. But in this way, in this example, I'm not going to each step explain you. Okay, in a brief idea, I'm going to complete. So optimizer, whenever you will do deep learning, that's the reason I'm mentioning all these points, because in deep learning you can understand what is the importance of Adam, what is the compiler importance, activation why needed, why we are doing all these things, because this is important. Okay, learning rate I have explained you, loss function I have explained you, and matches for the accuracy. Okay, now fit function for the training, same thing. Okay, so you can see little bit loss is happening, but the accuracy is quite poor. Why? Because clearly I mentioned that this is not a, this is a fine to train the system, but it's not a good thing that you will just arrange. You should do, if you're working on image processing, you should work on features, feature extraction algorithm. If you are working on supervised learning, if you are working on unsupervised learning, feature extraction will do automatically. The algorithm will do that. How? We will explain. Means I'll explain later when we will talk about CNN. Okay, so after that, okay, in previous time I use prediction, at this time I use evaluate. Both are fine. It's just like the multiple way I'm going to show you, the multiple things I'm going to show you. Okay, so just one, it will be trend, as I'm going to show you one point. Okay, so training will complete. Okay, an example, I have this image. That image I created with the help of a Paint. Okay, and I will store in this here. Actually, you can see yesterday 29. Yesterday, I have created this image. So we are going to check At this time, we are just working on the accuracy, well, what is the accuracy, all these things. But if we want to apply on our sample, what is going to be happening? So let's see. Okay, so here I have done evaluation. This is my system's performance, obviously quite poor, and I was expecting all these things. And after that, your performance will be in some as just a minute. As here we use this logic, okay, because we had the output in 0 or 1 means two output. Okay, so this is fine. But whenever you are working on images, so then I'll go with argmax, np.argmax. What it will do? Okay, just after this line, you will have output in some probability. I hope you can understand this point. Whenever you will do classification problem, an example you are giving sample A, okay, and the sample in A belongs to one class, first class or second class. What? So in between, some probability will come. An example, this is the probability, and obviously probability should be always 100. So the probability will come that, okay, so this belongs to which first class or second class. So what is who has high probability? The system will go in with this. So 0.6. Oh, this belongs to first class. Okay, so this probability will come. So when you run this command, means whenever you will not run this command, you will go within this way, the probability will show. So as a human, it will be tough for us to understand. Means each time you have to calculate, okay, who has high probability, the output will be accordingly. So it's quite irritating. So we can use this command, argmax. This will also do something. But human is going to be do that, oh, this belongs to this class. The algorithm will do that. Who has high priority, system will pick up that class easily. So that is also important. Okay, so after this, print y predicted, this one. So this is 0, 1 we have predicted. Okay. So after that confusion matrix, all these things is normal. Now I'm going to apply on this data set. Sorry, not this one. On this image. Okay, this is my sample image. I have called this image here and store in sample. Sample shape this means I have 3D image. Now we need 28 cross 28. If you can understand, we need in 28 cross 28. So we have to resize. So with this command, I have resized. Now I am again cross to check. So this point has been resized. Actually, this is a practical problem. Okay, there is no theory. This is the practically we are doing. Oh, this type of problems can occur. So 28 cross 28 is done, but not this 3. Third dimension is still 3 dimension. Okay, so what I have done, I have reshaped in dimension wise. Means earlier I have reshaped the size wise. Now I have reshaped. Okay, until I have done resizing. Now I have done reshaped. Means the shape 3D to 2D. So what I said the 0 means starting 2 is fine. The third will be 0. Okay, after that I have checked 28 cross 28. Okay, now my sample is fine, 28 cross 28. But you can understand one point. If you can recall, there is this type of number was there, and then 28 cross 28. And one time I said that this is the number of samples. Okay, that input we gave now means here my input should be in this form. Okay, always understand before fit function, before training, in this means the size of the image or what you have done means the size of the image should be similar. The size of the image which you are giving for prediction means for training size means before training, what was the image size? The similar size you should have when you're giving for testing. Size should be uniform. Okay, so that's the reason we are working on the size many times. So I have resized now the 1. Okay, now how? With the help of this command 1, comma this one. Okay, because of that. Okay, so after this run, my this size image I gave for input only. Obviously, apart from 1, there is a 60,000 if I'm not mistaken. Okay, so it's fine. So now after that I have run, and this is for not show probability, this is for just show the class. So I have run, the output is 0. Okay, 0 means it's belong to 0 class. So I have created a function. So I'm having the output that the sample belongs to 0th class. Okay, this is like how we can apply our data. Okay, and this is important, means in here this is the prediction we have done. Okay, so this is the way how we can apply our data, means on totally new samples for the testing. Because many times we are just like, no, we have data set split in a 2 category, training or testing, and apply and got the performance. But what will happen after that? If you want to come in a market product, there's some new data will come. How it will going to process? So in this way, that new sample is going to be processed. Okay, so here my ANN is completed. If you have any doubt, please feel free. Otherwise, we are going to start CNN. Any doubt? Yes or no?
No, ma'am.
Yeah, good. Actually, when students say no, ma'am, I always be worried that you are understanding, or just like no, just leave it like that. So you are getting now what I'm trying to say. Yeah. Now Abhinav came, huh? Okay, so let's start CNN. Okay, I hope all of you heard this name CNN because this is quite popular. Okay, always remember one thing: CNN is not algorithm. CNN is a model. Okay, model means the same model we created in ANN time, na? How many numbers of hidden layers, all these things, the network. And yeah, this is also CNN is also like a network or architecture or whatever you want to use a good word, but this is not an algorithm. This is the combination of small algorithms. Okay, again, small means in CNN it's a group of small technical work is happening behind, and when you are going to merge it, it becomes CNN. Now CNN means convolution neural network. So with the help of neural network word, you can understand that, oh, this is the part of neural network. Yes, this is a part of neural network, can say. Because without neural network, CNN has no, CNN cannot survive without neural network. Okay, it's just like I can say that CNN is a stand on the neural network. If the naive is neural network, the logic is neural network. That's the reason before CNN, I discussed the entire neural network thing. Okay, so now let's start how CNN, what is CNN? Okay, that is understand that, okay, CNN, the neural network will come in a frame. I'll explain in the last that how neural network will connect here. But apart from that, as I have said that there is a lot of layers, means architecture. No? So architecture will have some layers, and definitely each layer will have some work. So what is the layer? All these things. So let's see. Okay. And normal cases. Okay, I'm not going in encoder, decoder, all these places. In CNN means whenever you will go in depth, you can understand this, all those things. But at this time, I'm just saying that the entire today's class of CNN is going to be image perspective. Means we are giving image and what is happening with the image and how we are going to get output. All these things are going to be discussed today. How CNN will work with the numbers, CSV dataset, all these things I'm not going to be touched today, not at all. Because in CNN, I'm going to discuss with deep learning perspective, and deep learning image is very important. So entire the discussion, means 1 hour discussion, we are going to have only on image perspective. Okay. So in just earlier ANN, we have seen that when we give image, okay, when we give image 28 cross 28 2D image, just example, either we have to apply one feature extraction, otherwise my performance was poor. Okay, means either I can go with this point, or I have to I have issue with accuracy. Definitely it's not adjustable. I have to solve this problem, means I have to do feature extraction. So now with the help of ANN, means whenever I want to apply ANN, the feature extraction we can do separately. Means first feature extraction will do, then classifier will do. For classifier, ANN we are going to use. But in CNN, no need to do feature extraction separately. Means we are going to build a system who will do feature extraction inside the system. Means no outside we need anything. So this is the way that why CNN is quite popular, that it will able to do feature extraction by itself. Okay, so normal, I can say that this is your input. Obviously, input in image form, something is happening behind, and this is your output. And output will always depend on your, what is this? Or number of classes. Okay, so now the question will again come, what is happening behind? Again, now in ANN, header layer will working. Here, some another layer is working. Okay, but the layer is common. Okay, so here you can see many type of layer. Convolution layer, pooling layer, sorry, convolution layer, pooling layer, activation function, how it going to work, might be possible if we will have enough time. So we will talk about some more things. Dense layer, all these things. Okay, so let's start with convolution layer. What is the mean of convolution layer? We will discuss each layer and what is the function, how it is going to be work. So first, convolution layer. An example, this is your image. Okay, obviously image is not 2D. I hope you can understand. The image is black and white image, as you have only 0 and 1. Okay, now few word will come. You can heard a few word here. Filter. Okay, stride. Okay, this type of words will come. Let's see when the word will come. I'll explain you what is the meaning. Okay, now filter word come. Filter. Filter means outside a small filter you are going to create who will focus. It's just like now if normal human I'm saying, so it's just like a lens. If you have image and you want to cross check the image very deeply, so definitely you will use any lens or whatever to expand the image pixels, and then you will cross check. Normally this thing you can see when you want to check the authenticity of any image. So each small thing you are going to check that image, any picture is authenticated or not. So similarly, filter we are going to work, that filter will focus on each pixels of the image. Okay, and accordingly some calculation will happen, as there is a no brain mathematics. So some calculation will happen and it will convert into different image. Okay, means after that you will have an output of 2D, but in different, some modification will do. Okay, so this is the filter. Filter can be multiple. Obviously, it will be depend on the how many. Okay, it always be depend as this is your 2D. But if you want to convert into 3D, then you need to use 3 filters. Means how many number of filter you are going to use. That means how many number of dimension you want to increase. Okay, means 2D, 3D, 4D, 5D, and so on. So equal number of filters you can use. Why we need it? This is important. Okay, so why we need it? Later we will discuss. Okay, now let's see. This is my filter. Okay, this is my filter. Will cover from this area. So this is cross 3D to 3D. So this is my 3D area. It's covered by this filter. Okay. Now what calculation will do? Calculation will is very small, very simple. 1 multiply by this one plus 0 multiply by this. I think so I should change the color. This one. Okay. So 0 minus 1. Oh no, it's not visible here. Minus 1. Okay, now it's fine. I hope so. And 0 multiplied by minus 1 plus that point will multiply by this one. And so on. Okay, you can do it by yourself. So this value will new picture. This value will come here. Clear? So this type of filters will work. Now the new word will come in your frame, stride. Okay, stride. So what is the mean by stride here? Stride means, okay, this is a start, means this filter will apply on leftmost corner. Now you want to move. So how much you want to move? That will be defined by stride. By default, stride value will be 1 cross 1, or you can write down in 1 also. That is also be the number of rows and number of columns will always be equal. So there is no issue. So stride means you have to switch one column. One column is here. Means your new will be this area. Okay, so let's see. I think so. I have made a okay dot product. So output is 3. As just now, I'm going to explain how dot means how multiplication will do. Now stride 1. Okay, now you can see black box has been shift 1 point. Means earlier it was here. Now it has been shift here. Okay. Just a minute. I got that one chat. Filter matrix will always be same. Filter matrix will always be same. Ayush, what is the mean by filter matrix will always be same?
Ma'am, this 1 minus 1 minus 1.
Oh no. Any value can come. You can write down 1, 2, 3, 4. Anything. Okay. And this is not in a developer's hand. Okay, always understand this point. This is not in your hand. Means you are a developer now. You can define that what is the size. Okay. The algorithm working behind that will define this value, that which value will be should be here. And it's not a freeze. An example, you are working. After one batch, the hyperparameter is going to be updated as weight, bias, all these things in ANN. So similarly, a lot of things is updating here behind. So at this time, if system will feel that this is not a good value according to your requirement, so this value can also be updated. Okay, so any value can be here. There is no only should be equal same or not in this way. Okay, so yeah, are you clear this point?
Yes, ma'am.
Okay, so now stride. We have done one stride now. Now we'll go with sorry. Now we'll go if we have means the value is -1. Now we have 2 stride. If stride is 2, so what's going to be happen? This is 3. Now you can see 2 columns shifted. Okay, just understand in red part. Please focus on this area. That this is your 0 stride. Now you are going to stride 2. Means this is initial stage. Now you are stride 2. 2 column is shifted. Okay, so this is the mean that stride 1 and stride 2. But each time the calculation will be the same as I have mentioned you earlier. Now an example, this is your image. So image is 001, sorry 000, 001. Sorry, so sorry. 000, 001, 110. Okay, this is your this sample. That was sample. Okay, and this is your filter. So what will be the value will come? Obviously that will be directly 0. Leave it. That will be direct 0. Leave it, and it will leave it. So -1 multiplied by minus means 1 multiplied by -1 plus -1 -1 plus -1 -1. Okay, so what will be the -3 na? If I'm not mistaken, please cross check because I'm just doing in front of you. Okay, -3 I think so. Let's see. Yeah, -3. Okay, this is the mean stride. So we have discussed that how convolution value will calculate, means that is the will merge. So So your convolution layer will work now. So this is the working of convolution layer. What is the mean by stride, and how the calculation is happening, and what is the mean by filter, and how filter will help. Means number of filter equal to number of dimension. Okay, this is the important point. So all these three we have discussed. Any doubt, ask to me.
Ma'am, can you show this once again how -3 came? Like which two?
Okay, actually, the filter is overlapping this area. This is clear now, Ayush?
Yes, ma'am.
Okay, so 0, 0, 0, 0, 0, 1. I'm just extracting right down here. Okay, and 1, 1, 1. This is my the picture area where filter is overlapping. So we are just focusing here. This is my filter. So normally that value will multiply by this value. So 0 multiply by 1 plus sign. 0 multiply by -1 means now this will be multiplied by that value, plus this value 0 multiply by -1. Okay, plus. Okay, all these things plus 0 multiply by -1 plus 0 multiply by 1 plus 0 multiply by -1 plus 1 multiply by -1, as there is a 1, there is a -1, plus 1 multiply by -1 plus 1 multiply by 1. Okay, so that will be 0.
110, ma'am. 110 in the matrix, last third row.
110. Okay, so 110. Fine. Any means any another mistake I've done? So this is 0. That is 0. That is going to be 0. That is going to be 0. No. Then this is 1. Okay, I made a mistake. That is 1. Okay, 1 minus 1. That number. Okay, this is 0. So this number will come 1 cross multiply plus that number will come 1 multiply by -1 plus 1 multiply by -1. Okay, rest are 0. So this is -1 plus -1 plus -1. So -3. So this will be pixels of means the new pixel. Now clear? Abhinav? Oh, sorry, Ayush.
Yes, ma'am. This value will be updated when in the 6x6 image.
I'm coming on that. I'm coming on that. I just think that how calculation is happening. Okay. Okay. So now you can understand. Okay. First, I think so. I should change the color. Okay. Okay. Just see if we are able to see the color. Now my first image was here. Means the first filter overlapped this area. Okay. So one value came. Now my second. Sorry, 2 stride. No? So my second focus on this area. Okay, and third will focus in this area. You can say that, ma'am, there is a no value, leave it, no issue. So last column will not work here in this case. Means this column will not work in this way. Okay, after that, okay, stride is 2. So in bottom also 2 rows will leave. So this value, okay, please count how many number of boxes we have. 3 in one row. 3 here and 3 here. Okay, again 3. So if I'm not mistaken, total 9 values we are going to have. So after that, if I'm not mistaken, I'm going to have 3 cross 3 matrix. 3 cross 3 matrix. Okay, so what will be the value of 3 cross 3 matrix? So this is the first 2 values. One some value will come. Okay, so this is it. Now the question should come that, okay, ma'am, are we going to calculate manually each step? Just I have done in this way. So my answer is no. We are not going to do in this way. There is a formula for this. Just a minute. Filter is 3. Stride is 2. Okay, so the real formula, actually I was trying in starting I was thinking to connect in this way. Okay, just leave it how the matrix will come. After some minute, I'm going to explain. Otherwise, my sequence will be dropped. Okay. So just at this time, please understand that how we are going to calculate the pixels value, how we are going to arrange these pixels value. Later we will discuss. So in this way, you are going to connect. Okay. So now here, start. This is exact example. You have this filter size. You have this image, 6x6. Here, obviously, this 0, so that will be 0, and that will be 0. Only these three will work together. So that easily you can multiply 1 cross 1, 1 cross 1, 1 cross 1, 3 value. Means this is the first value we can follow. Okay. After that, one is strider. So next value, -1. Okay. Next value. So okay. So in this way, all values is this. Now you can see we got the image 4 cross 4. Okay, we had image 6 cross 6. We got image 4 cross 4. Until here, any doubt? Please ask to me, because now we are following second step. Any doubt? Yes or no?
No.
No. Okay. Well, okay. Now the formula that if we have this image and if we want to miss output, so what will be the output? Obviously, there should be a formula. So formula is, please correct me if I'm writing wrong, because I'm just writing in front of you. N plus 2p minus f divided by s plus 1. Okay, where n is this. Okay, that is always the square. So n is equal to 6. We are not doing any padding, as padding is not we discuss now. Okay, so put it behind that what is the mean by padding. Please leave it at this time. Just understand that padding is 0, f is 3, and s is 1. Okay, please put in this equation what the value is coming. And this is not a minus sign, this is a positive sign. So please check. Four. So we are having output 4 cross 4. Clear? How we are going to cross check whether the output is right or not? Bacho, clear or any doubt? Okay. Now the question should come that, ma'am, what is this? And again, if its question is not coming, you should rethink. Okay, so the question is, what is padding? So before to padding topic, I'm going to say in different perspective that we had this formula 2p minus f divided by s plus 1, and that is my output image. Okay, I'm just taking previous example when we had 6 cross 6 image. The filter size was 3 cross 3. Stride was 1. Yeah, and output was 4. Okay, that I had. Okay, so you should understand this question, this point, that my input was this. Means my input was 6 cross 6, and I'm having 4 cross 4 output. Means normally you can say that, ma'am, size decrease. Easy now? Decrease the size. Yeah, it's easy to say that decrease the size. But the question is, but when you decrease the size, you lost some information. Clear? When you decrease the size, you lost some information. Means, as the normal condition, my input is 6 cross 6, my output also be cross 6 to 6. So I can say that I didn't lose any information. But in this case, I lost some information. So what to do? The question should come. Means if I have a problem, means I can analyze that. No, this is the problem, that I had image 6x6. As an output, I'm having image 4x4. Means some loss I have, because input output should be equal. So what is this? How this problem can solve? Let's see how this problem can solve. Okay, so just imagine that this is the value 6, that is f was 3, stride was 1, that is 4. Means just a previous example, nothing else. So 6 plus 2p minus 3 upon 1 plus 1 is equal to 4. Okay, so ye kitna, what is this? 3 na? And hey, I made some mistake. Did I? 6 2p. Let's see. 2p plus 3. So plus 4 is equal to 4. So, okay, yeah, padding was 0. Yes, right. Padding was 0 in this case. Yes, definitely we didn't do any padding. Actually, that is not a right thing. The right thing is that my input size is 6x6. Okay. My input size 6x6. So my output should be 6. Means I'm expecting that my input was 6, so my output also should be 6. Now what to do? So 6 plus 2p minus 3 upon 1 plus 1 is equal to 6. This is hypothetically I'm saying, nothing is happening, means nothing I'm saying with the example, just a hypothetically that my input is 6 plus 6, my output should be 6 plus 6. Now what to do? So just calculate, that is 2p plus 3, 4, 2 plus 6. So 2p is equal to 4, 6 minus 4, 2p. So p is equal to 2 divided by 2 is 1. Means my padding should be 1. Okay, my p value should be 1. Padding. But what is the padding? Because we didn't discuss. But that is, we can say that if we want to use this, if we want the same size, that padding is important for this case, this example. Okay, means now the padding will come in a picture. That what is padding? Okay, padding is nothing, very easily thing. The padding will do that. Okay, padding will do an example. You have this image. So there is a one column, one row, one column, one row will add in all size, means all 4 size. Okay, so that is understandable. Okay, means some rows and some column and some rows. I have to means some means 1. Padding was 1 in previous example. So I'm just saying 1 means 1 rows, 1 column. I have to add. That is fine. But what will be the value of the row and column? We do not know. Okay, now you can follow 2 algorithms. For me, 2 way, not directly algorithm. 2 way to follow this thing. Either you can replace with all 0. Okay, all 0. That is the one way. Means you are adding one padding. One padding means 1 row, 1 column you are adding in all 4 direction. Fine. And all value means obviously if you are adding 1 row, you are adding just a row, but what the value in between the row and column? So value will be 0. This is the one way. Now, what is the second way? The second way is what value you have. You can just write down here. Means just duplicate the value, nothing else. Okay, so this is the second way which you can follow. Okay, this is not that much good. So people like to follow 0 padding. 0 padding means when all these values were 0, 0, 0, 0, all value were 0. So this is called 0 padding, and 0 padding is very well. So when you apply 0 padding, okay, here an example now. Again, calculate n plus 2p minus f divided by S plus 1. N is 6 plus 2 multiplied by 1. As padding is here 1, I'm doing it. An example, hypothetically. The filter is 3, S is 1 plus 1. Calculate this value. 8, 5. Okay, yeah. 5 divided by 1 plus 1, 6. Means my output will be 6 cross 6. So what the problem was created? Means we discussed the problem that the information loss. So with the help of this padding, the information cannot be lost. So that's the reason that padding came. Okay, and this is the way how we can work on a padding. And this is the the mathematically that how use means padding, how directly can work to increase the size of the output. Okay, and which type of two type of padding we can follow? Normally zero padding is popular. So until here we had talked about the convolution layer, the padding. Again I'm asking, any doubt, ask to me, because after that very few things is left. After that we will do implementation. So any doubt, please ask to me. And this is a important, CNN is important. Okay, no doubt, well and good. Okay, now 3 image. If you have 3 image, nothing worry. 3 image means your third dimension. Means an example, 28 cross 28 cross 3, that 3. So there's no need to be worried. If you have one filter, okay, so this 3 means an example, this is your 1, this is your second, and this is your 3. So this one filter will apply here, and you will have this image. That same filter you can apply here, you will have second image, and the same filter you can apply here, and you can have third image. Means 3D will be as it is. If you want to increase, if you will increase the filter size, if an example you have 2 filter, so this will be 6 directly. How? 3 into 2 combination. An example, you have filter 1, filter 2. So filter 1 will apply 3 times. Filter 2 will apply 3 times. So you will have 6 filters, means 6D. It becomes 3D image will convert into 6-dimensional image. Okay, just because of the filter. As I have mentioned you earlier, that number of features, number of filter is equal to number of dimension. Okay, but in this case, in the earlier dimension should be 1. If there is a 3 dimension, so it will be multiplied. Okay, so there is a nothing means, as you can see here. Okay, until here we have discussed 2 topics. Now third topic, max pooling. Now the question should come that why max pooling is important. So understand that point that there is a lot of an example, you have an image with a multiple object. So in a specific reason you have some object now. So for a specific reason you want to expand. So max pooling came just for the feature extraction. At this time we are just doing feature extraction. We are not doing any classification thing. This is the entire work for the feature extraction. As you can see, this is the 2D 2-dimension data set we are having, or 3-dimension, not 1-dimension. So until we will not get 1-dimension data set, we cannot apply classifier. So whatever we are doing, it's a feature extraction. So max pooling. Now max pooling also we need filter. Okay, so this is my output of previous. Okay, until here we have done the same image we are working. Okay, this is my image. This is the image entire time I'm going to use. So please keep it in mind. So this is my image. Okay, again filter is a developer's fault. So I have said that okay, 3 cross 3 filter I can have. So 3 cross 3. Okay, now the pooling, I should not write max word here. The pooling, okay, pooling can be 3 types: max pooling, average, AVG, average pooling, and minimum pooling. Okay, so now the importance I have mentioned that okay, each area you want to focus, so pooling is important. Now what is the mean? Okay, an example, this is your area, 3 cross 3. Okay, so just let's see. I hope they have in the PPT we have mentioned in a good way. Just a minute. 3 minus 3. Please take a screenshot of this image. I think so. I made a mistake. Okay. I didn't make a mistake. The representation was wrong. Okay, little bit low. Okay, so an example. This is my when I apply filter 1. Okay, earlier I have mentioned two filter. So when I apply filter 1, my output is this. When I apply filter 2, my output is this. Okay, now until here we didn't apply max pooling. Now the max pooling will come. Okay, so what do you want to miss? What is the size of max pooling? Normally you can go with 2 cross 2. So 2 cross 2 means this image will divide it into 2 cross 2. Means this is my first 2 cross 2. This is my second 2 cross 2. Okay. So if I'm going with max pooling, with maximum value of first region. So what is the maximum value? 3. Okay. So my output will be 3. Now we'll focus in here. What is the maximum value? 0.
0.
What will be the maximum value here?
3.
What will be the maximum value here?
1.
1. Okay. Means I'm not able to see so. Okay. So this is my after max pooling. That will be my image. Means this image after max pooling I have converted in this form. Means I have found out that this pixels is important, rest are not important for me, and I have minimized the size also. Okay. Now the question will come that okay, we are taking maximum value and this is the max pooling, and this is quite famous. If I'm taking average pooling, nothing, simple. You have to calculate average value. So average value of this region. So what will be the 3 plus minus 1 plus minus 3 plus 1 divided by 4?
0.
So whatever the value will come, you will get 2 cross 2 image. Okay, after this. Similarly, minimum pooling. Minimum is minimum value you have to focus. So there is a 3 type of pooling you can follow. Quite simple. That maximum value, minimum value, average value. So in this way, after that, you will have a this is your value in red color. No? Okay. So means you had another means 4 cross 4 image. Now you have converted into 2 cross 2D image, 2 cross 2. Okay, that for filter 1 and similarly for filter 2. Now, okay, max pooling we have discussed, all these things we have discussed. As I said, that important area we are going to focus and shrink means shrink the image. Okay, so the word is big, word is small. Resampling, yeah, that is a better word. Okay. Okay, now we have discussed max pooling, we have discussed all these things. Means all this means 3 topics we have discussed.
Pooling, are we losing data again? Like we are losing some features?
No, this is the good thing that as you can see here.
Because you are converting 4D to 2D, right? So
actually, are you
maximum pool?
If you will ask to me as that, ma'am, we are going to, yes, definitely, few things we are going to lose 100% each time. Even if you are following that filter earlier, now the size is same, but information definitely we are going to lose. And that's the reason we are not 100% accurate. Means any module is not 100% accurate. But hypothetically saying that we are not losing any, means we are trying to minimize the loss. But 100% you are losing some important thing. But in max pooling or any pooling, you will just focus on any specific reason. An example, in this image, this is important, that is important, this is important. So with the help of, we are focusing on each zone now. So we will focus on each zone and find out that which feature is important, which is not important. So it's just like a little bit depth we are focusing. So if you're asking in a practical way, so definitely we are losing some information.
Okay.
Okay. So now, okay, we have convert thing. Now we have done a lot of illustration. Now talk about the classification. I have mentioned you many times. This is the image. is this one 0 1 3 1. Okay, so 0 1 3 0 1. Okay, where is 0 1 3 1. Okay, this is the arrangement is little bit wrong, I think so. 0 1 3 0. Okay, and this is second image. So this is the image I have arranged in. This is my image. Okay, the two filter. So 2D image I have. Means sorry. Yeah, two layers I have. One layer is you can see in a gray color. This is front layer, and that is back layer of an image. Now, now we are working on classification. We are going on classification. We have done a lot of featurization. Now, how we can go? Just ANN as we have done. Just arrange it into one dimension. Nothing else. Okay, but flatten layer is very important, and many times understand this point. Many times you cannot see this thing in a whenever you will write down any documentation. Flatten layer many times they didn't mention. But you have to understand when 2D data. Okay, don't confuse with this thing that ma'am this is 2D data because of this or because of this means two layer. Okay, just is like whenever you have multiple data, multiple layer, and whenever you are going to convert into one dimension, first time definitely you are working on flattening layer. Definitely in CNN I'm talking, means deep learning I'm saying. So how you are going to arrange in this way? Okay, you have arranged it. Now after that fully connected layer will come. Normally fully connected layer they have write down FC. So you can understand now ANN came. As I've told you that ANN is very important. Okay, now ANN came. This is your input. How many hidden layers do you want? You can take, and output number of classes. Okay, so fully connected layer is nothing but ANN. Okay, so this is the way. That's the reason why CNN called a part of ANN. So ANN we have discussed. So I'm not going to discuss that how feedware forward or fully connected layer will work. This is the way. I have just explained this, how you are going to connect it. Okay, so this is the everything. An example, you are going to create a model. So this is on in your hand where you want to apply CNN, where you convolution layer, when you want to apply maximally layer. It's your hand. Your hand means as a developer. This is your decision. Okay, so until here, the CNN is completed. If you have any doubt, please ask to me. Otherwise, we are going to, otherwise we are going to apply. Means we are going to create a model. So any doubt related to CNN, please feel free to ask to me. Or this is going to be last experiment. The next experiment I'm not going to run. Okay, so this is your last one. So after that, we are going to end this session. So until CNN, if you have any doubt, please feel free. Or if you do not have, please say no, so I can continue. Any doubt?
No.
Okay, so let's start. Okay, so this is your MNIST dataset. I'm taking again as I have done. This is fashion MNIST dataset. Okay, earlier I have taken MNIST dataset. Just a minute, I should Google first. What is MNIST dataset? Fashion MNIST. Okay, I'm just explaining you a little bit idea about the MNIST dataset. This is fashion MNIST dataset who has 60,000 training, 10,000 testing. Okay, 28 cross 28 image size and 10 classes. Okay, but remember one point: the classes is mentioned in a characters, not numbers. Okay, means we have to convert into numbers. Okay, only this point is important here, that label dataset is in a categorical dataset in this way, in this problem. So we have to convert into number. This is a little bit small, the focus point. The rest are fine. So this is our dataset. Okay, so I have import this data set. Okay, on all examples, I have import only data set. But it might be possible that you are working and your data set is in image form or some another form, and you have to recall it. So there is another way. Actually, if we will have enough time, so I'll explain you that point also. But again, if we will have enough time, if we will not have, this experiment will be last experiment. Okay, so this is same thing. The import I have done extend means target data set, training data set, target data set for testing, and training data set, testing data set, as we have done earlier. Okay, I'm not going to run as this is quite taking time to experiment. So after that, what is this? The packages. So this is the packages we are going to import and some print, nothing else. Okay, so this is the print I have done as we have done earlier. Okay, now label. Okay, label come in a frame. That label should be numbers now. So there is only 10 numbers. So 0, 1, 2, 3, 10 we can define easily. If there is only 10 classes now. So 0, 1, 2, 3, 4, 5, 6 can define easily, not a big problem. So there is a third algorithm we use, unique number. Unique number, what we'll do? We'll assign 0 to whatever classes we have. An example, we have 15. So 0, 1, 2, 3, 4, 5 until 14. I'm taking 0, so I'm not taking 15. So don't confuse with this thing. So if I have 15 classes, so 0 to 14 value will I have. So with there is a very small, very simple algorithm, a function you can use, the unique function, np.unique, and apply on target data set. Okay. So after that, when you run it, number of output is 10, means number of classes in an output layer is 10, and the classes will be 0 to 9. Okay, again 0 we are considering, so 10 will not come. Okay, now print some images. So I'm going to print some images. The print plot function figure, and figure size 5 cos 5. Okay, means the figure size is 5 cos 5. The figure size means this one, x-axis and y-axis, 5 cos 5. Okay, and the gray color shows all these things is fine. Only the thing is which figure we want to print. Okay, this one figure. Okay, the trend means trend by data set, focus on 0 first figure, and this testing data set focus on 0 first figure. So this is the figure is going to be print here just for the cross check. It's optional, totally optional, totally optional. There is nothing. It's just like for the fun. Okay, now pre-processing. Why we need pre-processing? Definitely for CNN we need three dimension, not 2 dimension. ANN 2 dimension was fine. Okay, the first is mentioned by the number of the samples. So I'm not considering those. This is a dimension. As here, this is when I'm saying, okay, as a written, it's a 4 dimension, you can say, but when I'm saying it, it means that this is the number of samples. So just leave it. I'm just saying that earlier it was 28 cross 28, but at this time we need 28 cross 28 cross 1 also. Okay. So we have to convert it. So reshape. The reshape command is quite easy. We have used earlier the reshape according to requirement. Okay. After that, again, I said that use a step that if you want to use it, this one, so normalization. So if you want to use it, can use. If you do not want to use it, you cannot. Other little bit performance can be up and down. I'm not saying that this is not a good and another is bad, because it's always be depend on the data set. Okay. So, but if you want to miss the simple thing, na, if you want to the pixel value 0 to 1, okay, I'm not saying 0 and 1. There is a difference. 0, 1 black and white. 0 to 1 might be color. Oh, sorry, might be gray. So when I'm dividing by 255, so my all value will be in this range. So it will be easy and the training can be fast. This is the advantage. So I have done this point. Okay, after that, target data set. Why data set is target data set? Just a minute. See, we have done already, no? Why it be done twice? No. We have done already. No need to do twice. Okay. So after that, split. Okay. Now you can ask to me that, ma'am, already training and testing. Why we are splitting it? For validation, you can do. It's also optional, as we have done here. Okay. As you can see here, you have already training and testing data set. Means the data set is already divided into training and testing. So this is optional. This step, do you want to use or not? If we want to use, so how means why we are need it? So only one function is, whenever you will divide it here, training and testing. So training part will be focused for training, and the rest part you can focus for validation. Means now you have 3 type of data set now. One for training, one for validation, one for testing. I hope in a morning session you heard this word validation. And if you didn't heard this word, leave it. Training testing is fine. Later you can do Google. That what is the mean by validation. Okay, the small thing I can explain you now, that validation means when you are doing training, at the same time, some data set we are going to give to the system that the performance will check parallelly. Okay, but that is not a testing data set, so don't worry. Now, as I said that you can create your own model. It's totally up to you. So I have created this model. Actually, I didn't create, honestly speaking. I took it from some blog. Okay, so there is no copyright from my side. I'm not saying that means there's no copyright issue from my side. I find out this figure and it was look good, so I just took it. Okay, so my image is this size. After that, I'm applying convolution layer. Convolution layer, this is my 32 is my, just a minute, 32, 3 × 3 is my filter. And if there is a not mention, so stride is 1. Okay, if there is a not mention, so stride is 1. Just let me check. 32. Okay, 32 is number of filters. Number of filters. So I had one image, means 1 dimension. Third dimension is 1. So 32 means after that I'll have cross 32 in the last. Okay, we'll show in practically way that how we are going to use it. After that, max pooling, the size is 2 × 2. After that, convolution, this is my number of filter. This is my filter size. Stride again not mentioned, so 1 stride. By default, 1 stride. And padding is not mentioned, means by default is 0 padding. Okay, by default, padding is 0 and stride is 1. This is by default. So if there is not mentioned, please take it, consider it. Or if you are using any deep learning architecture, so please check the architecture first. Might be possible in the figure this is not mentioned, but somewhere it's mentioned. So if you are using predefined function, some architecture, LXNet, VGG, whatever, so please study carefully. Okay, again after that, max pooling, convolution layer, and so on. This is we are going to discuss. Now we have 2 ways to develop it. Both I'm going to discuss. This is the one way, and the same way which we develop in model is equal to sequential, and after the model, in model, okay, add 1 convolution layer. Convolution layer means convolution 2D. Okay, here I have explained that convolution 2D is an import from Keras layer. Okay, so no need to write down the entire code. Convolution 2D is fine. So first layer is convolution 2D. What was how many filters? 32. What was the kernel size of the filter? Kernel size is filter size. 3. Padding, same. Means, okay, 2 type of padding you can see, same and valid, if I'm not mistaken. Same means the size will be same. Okay, means directly or indirectly, no padding is going to be applied. Means, sorry, the size will be similar. Okay, and input size is 28 × 28 × 1, and activation function is relu. After that, I'm going to apply second max pooling 2D. Okay, max pooling the 2 × 2 size. Padding is same. convolution again, third convolution, 64 cross 3 cross 3. So convolution 2D, filter 64, kernel size 3 cross 3, padding same, activation value. Max pooling 2, same copy paste this line, that line, nothing else. Only filter size is changed. Sorry, number of filters is changing. Rest are similar. Earlier 32, 64, 124. Okay. After that, okay. In this figure, that's the reason I took this figure, that flatten layer was mentioned, but normally this is not mentioned. Directly max pooling. After that, you can see dense layer. Dense layer means this is a part of ANN. Okay. When I saw ANN, this is the part of ANN. So flatten layer is not mentioned most of the time. So always remember this thing. Before dense layer, there should be, okay, but multiple dimension to one dimension you want to convert. So definitely flatten layer is important. Okay, so one flatten layer. After the dense layer, the size of dense layer is 128. Activation function is value. Okay. Now output layer. This is important. So output layer is number of classes. How many number of classes? 10. And that's the reason when I took in ANN, I took 1. That time I said, in later I'll show you in how to do in multiple numbers also. So here you can see the number of classes 10. Okay, and activation is softmax. Okay, now this model I have created. I have just note down these points. After model creation, you have to do optimizer and compiler. You have to. So what optimizer I'm using? Adam. This is my favorite, so I'm using it. And there is a good also, but not best. Good. And compile model.compile by using this parameter. Okay, so this is the summary of my model. You can see this is the output shape. That was my input was 28 cross 28 cross 1, but 32 filters I used, so it becomes 28 cross 28 cross 32. After that, some size decrease 14 cross 14, 32, because I used max pooling 2D. So 50% is decreased. Okay, after that I used convolution. So size was same, but filter was 64. After that I used max pooling 2 dimension. So again 50% is changed. So 14 cross 14 becomes 7 cross 7, and filter was same. Okay, after that I used convolution. So 7 cross 7 is similar, but filter was changed. Means you can understand when you are using convolution, in this case, the number of filter is increasing, the size is same. But when you are using max pooling, the number of filter is similar, but the size is decreasing 50% because you use 2 cross 2. Okay, and after that, okay, just much after max pooling means that just a minute. This max pooling layer. After that, our image becomes this size. Okay. Now you want to convert into 1D. So what will be the conversion? Nothing, only 4 cross 4 cross 128. As you can see here, 2 cross 48. 2 cross 48 means nothing is lost. Only you arrange in 1D. As then we did with ANN 28 cross 28. So we just arrange it. That time we discussed this point. Okay, so I'm just recalling that where we have discussed. I'm not going to discuss again and again many times this point. After that, flatten layer, dense layer 128 unit. Okay, so dense layer 128 unit means you have converted this into 128. After that, you are going to convert into 10 classes. So this is your output. Okay, after that I have trend. Definitely the trend is for you can use fit function easily as you have done earlier. Only this was the tricky part which I have just explained until here. That was the tricky thing. Rest are similar. Training you have done, fit function. After that, evaluate, testing you can do. Okay, after that print you can some graph you can plot. So what is the training accuracy, what is the validation accuracy, similarly what is the loss, training loss, and all these things you can do. It's fine. Okay, that is the point which I want to say. Okay, predict the class means now you're predicting your system. Test X. This is your target data, testing data set. So predict you used. The evaluate we can also use. I used earlier. Okay, predict also. Model dot predict, model my model name, test. Okay, predict the class. Okay, so the class you can see, you are having this class in this way. Means the value. As I mentioned earlier, the probability will come. Definitely. So what you have to, okay, shape is, this is number of sample and 10 class. Means 10 output can come now. So this is means size. The similar na bacha. Means this is quite similar thing. You gave one input. Okay, you gave one input. So 1, 2, 3, 4, and so on 10. So this is what is the probability that this belongs to this class. An example x1, x2, x3, and so on. Now you are giving second. So second will come here, third will come here. Means this is the x will be number of sample, and the y will be number of classes. So number of sample was this, number of classes is this. Simple. Okay, we are talking about the testing now. So now the question should come definitely that, ma'am, we are having probability. Simple. Argmax function you can use to convert it. So predicting class you have converted. Okay, so actually I didn't run this command. It's fine. Let's run. Okay, now you are having 0 point some class name. I hope you can understand that one class belongs to 0 class means t-shirt, 1 class means trouser. Okay, 9 class means ankle boot. Okay, so you can see here, this is your ankle boot. Predicted was 9 and class was 9. Means class means this is a real target and this is your prediction. So cross check how many is right, how many is wrong. So this is the command which you can follow to predict that number of classes. So found this is number of classes, corrected classes. Okay, at the same command for wrong prediction. As you can see, the prediction is 5, but it belongs to 9. The prediction is 2, but it belongs to 4. Means wrong prediction. So how many wrong? This number. Okay, so in this way, it's just a representation, nothing else. And this is your classification report. And this is the good thing, means some precision confusion matrix. In a morning session, you have discussed all these things. Okay, so this is the way to do coding. So we have talked about the CNN, all these things. Now, because we are in the end of the time, so there's only 5 minutes. So please ask to me if you have any doubt. Okay, any doubt related to any code. Means or curious, anything you can ask. Any question, bacha? Anyone?
Ma'am, what about the classes we found some incorrect, right? So what can we do for that?
Okay, if you will ask to me at this time, means if you are just asking in a CNN perspective, so I can say that leave it. If you will ask to me in assemble technique, so I'll suggest you to go with bagging boosting. I think so boost stepping, bagging boosting. I think so boosting you can use. Okay, those students who has no idea, means those students who are not belong to, you never learn about the bagging boosting thing. Please leave this point, as he's my student and I know that I have taught him. So I'm just connecting in that way. Okay, so if you means any student, please don't be confused if you have no idea that what ma'am is saying. Ignore it. There is another things. Apart from any question.
No, ma'am.
No, Arun. Yeah. Okay, so we are good to go. Okay, so Deepa ma'am, are you here? Deepa ma'am, are you here?
Yes, ma'am. Yeah.
Okay, yeah, ma'am. We are good to go.
Completed, ma'am, session?
Yes, ma'am. Completed.
Okay. Yeah. Thank you all for attending this session. Thank you, ma'am, for a very good hands-on session. It was very interesting. So thank you all.
Thank you so much.
We'll
Okay.
be posting a feedback link and quiz link in the chat box and Telegram group. Please fill that.
Sure. And if anybody has any doubt related to this thing or anything, feel free to contact me. Okay. Whatever you want to discuss with ANN, CNN, and machine learning, whatever, feel free. I'm in a university. So thank you. Thank you so much. Bye. Yeah, you can ask me in a class. Don't worry. So ma'am, can I leave?
Yes, ma'am. Thank you.
Thank you. Thank you.
So we have posted both quiz link and feedback link in the chat box. Please fill that. So I thank you all for attending the session. I thank all the volunteers who are supporting this workshop from the morning to evening. Thank you all.